artificial neural network with three neurons in hidden layer, and for traditional curve fitting. As you can see, the most significant improvement is for outdoor, where root mean square error is lower about 2 centimeters, and a maximum absolute error is lower by 3 centimeters for both type of passages, for smooth and start-stop in the outdoor environment. Now you can see the example results of distance correction with the use of artificial neural network with 3 neurons in one hidden layer. On the left, there is an example of smooth passage indoor, and on the right, there is an example of start-stop passage outdoor. The blue is the raw UWB data on both figures. The red one is the LiDAR data. In fact, we can see clearly this data, but I think it's good because in yellow, we have a corrected value from UWB system. And we can see that the data are moved based on the distance correction function very well for both environments, and in fact lay on the LiDAR data. And now short summary and conclusion. Comparing the artificial neural network with 3 neurons in one hidden layer, the improvement is 74 percentage points looking at the proposed metric. So this metric which we introduced in this research. The root mean square error is lower by 16 centimeters, so it is about 60%. And median of absolute error is lower by 18 centimeters. With one relatively simple network model, because we have only one hidden layer with 3 neurons, it is possible to model the error change for both environment at the same time. The neural network can also be easily extended with additional features, for example, UWB signal strength or obstacle detection from, I don't know, LiDAR system, which can also improve the accuracy of this system, the prediction of this error. Thank you very much for your attention, and I'm waiting for your questions and suggestions.
Okay, thank you for your presentation, and now it's time for discussion. We have 1 minute. No questions? So once again, thank you for your presentation, and we go quickly to the third presentation. The third presentation is of my PhD student, Mr. Ernest Antolak.
Hello. Oh, my village. Oh, okay. Everything is all right. You see my screen?
Yes.
Okay, yes, we can see it. Okay, so
ladies and gentlemen, let me introduce myself. My name is Ernest. I am a PhD student at Silesian University of Technology in Gliwice. I am working on designing real-time systems. So, my talk was divided into the 5 parts. For easier distinction, I marked them with colors. In the green part, I will remind you a basic definition and present the purpose of our research. In the next part, I would like to show you our previous ideas, which we use in the presented system. In red section, I am planning to look at the new ideas introduced for this conference. Next, I show you a model of our system and test scenarios will help to get the results. In blue part, I will represent research results, and at the end, I'm going to talk about conclusions. Okay, so the overall goal of our research is to develop a real-time system with flexible hardware. This type of system will be a static. It means the quantity and type of resources will be automatically adjust the task at the planning stage. If such system will be designed according to our methodology, it is not possible that the task will not be complete on the time. In this presentation, I would like to present application of our system in practical use. So as an example, we choose a model of a substance mixer. Modern processors almost always use pipelines. Thanks to that, they are faster. Unfortunately, this method introduces a lot of time unpredictability. The reason for this is that the fifth instruction are processed in parallel. We see this in this diagram, and this one piece of time is many instruction processed in one time. Some of this instruction disrupt the pipeline. For example, jump instruction cause unpredictability of instruction execution duration. Something like this is named data and steering hazard and is unacceptable in our application. So threat interleaving is a method introduced by Professor Edward Lee from University of California at Berkeley. And in short, in this method, CPU process in parallel instruction of different threads. So in the previous slide, we in one piece of time process the different instruction. And in this method, we process the different threads. For example, jump instruction do not disrupt the pipeline because on clock cycle, only one stage of instruction is being processed. This method cancel data and steering hazards. Okay, so let's move to the next yellow section, which is our ideas. So we would like to introduce our extended thread interleaving. In previous work, we implemented individual memories, program and date for each thread. So next we noticed that always when on-thread memory is busy, in the next clock cycle that thread's memory is free. In this diagram, we will see in red color we mark when the memory is used, and always in the next clock cycle this thread memory is free. So we use this for data exchange between threads. So it means that always the clock cycle on the next clock cycle, we can do data exchange. The main source of unpredictability in processors is data and steering hazard and cache memories or data exchange between cores. So thread interleaving can solve the first problem, and our solution, the extended thread interleaving, can solve the second problem. Our second idea is flexibility of system. Numbers of cores and threads is fully parameterized. So at the beginning, at the design stage of system, basing of the number of the task and their time requirements, the number of cores and threads can be calculated. We design algorithm for this. The core of the system has been designed in this way that when we increase the number of threads, only 5 necessary modules will be added. For example, the general purpose register, the size of multiplexer to switching data for threads, instruction bus, memory bus, I/O ports, general bus. In this system application directed at this conference, we add 2 additional pipeline stages. They are used for switching data from memory, select instruction address, switches instruction from program memory, and the select memory address switches data from data memory. Unfortunately, we have not checked their impact on the system because their function was to increase the maximum frequency of system clock, and this system has not been synthesized yet. In this application, we also decided to implement a global thread supervisor. Dedicated thread can turn on and turn off other threads. Also, only supervisor can initiate the data swap with the other threads. Implementation of hierarchy of threads allowed to calculate time easily and also allowed to define predictability at the level of a single clock cycle. We choose as the test environment the model of a substance mixer. Each thread controls only one valve and calculates the amount of substance based on a time of open valve. Before mixing process, supervisor sent to each thread valve opening time. Next, it turned on all of threads immediately. As the time set by supervisor passes, valves close and substance is being measured out. The valve open in parallel with full time predictability. Before testing, we made some assumptions. We always mix 29 substance and use 30 threads, 29 utility threads, and 1 control supervisor. To time calculation, we made assumption of 500 MHz system clock. Test was placed in 5 variants depending on the system configuration. We changed that distribution of 30 threads between different number of cores from 1 core to 6 cores. In first diagram, I would like to introduce difference between having 1 core or 6 cores with valve open duration. First substance should be open for on loop program. So 2 instructions. This is a time for minimal time of opening valve with different scenario. So to the opening valve, we need 2 instructions: the loop counter tracking and the potential switching of valve. So when we need to calculate time with this scenario, we have 30 threads, 30 interleaving threads. So we must multiply 30 threads by 2 instructions. Is 60 clock cycles. So the time is 120 nanoseconds. In the second scenario, we have 5 interleaving threads. So we must 5 multiplied by 2 is 10 clock cycles. So we need 20 nanoseconds. 20 nanoseconds is minimal time of valve open in this scenario. In this slide, I'd like to present relationships between scenario and cut down accuracy. The time valves were calculated at the same way as on the previous slide. So this diagram is linear because when we look at this scenario, and here we have 30 threads. So to 5 threads, we must divide this for 6. So 120 by 6 is 20. So this is linear. Is the same in this scenario. 40 by 2 is 20. So this is relationship is fully linear. In this diagram, I would like to present duration of mixing of the substance that depend on quantity of threads interleaving. So with more cores, valves open in parallel, this is mixing duration is faster. If we have a 6 core, this is duration of mixing was 6 times less in 1 core. In the last slide with results, I'd like to focus on supervisor thread. Duration of the data sending will be different depending on the interleaving size. Because this system is true real-time system, we can calculate execution time of a program basing of the number and type of instruction. Supervisor need 123 standard instruction and 30 setting instruction to be executed. Setting instruction is used to send data to other threads. So in the first table, we place the equivalent of execution time with standard instructions. So in this scenario, we need three standard instruction to execute one setting instruction. So in the second table, we exchange the instruction into execution time, the clock cycles to the execution time. So this is my estimation time with calculation. And in the last column, we present the values coming from the simulator. In every scenario, we notice a difference between the theoretical value and the timing parameter read from simulation result. This inaccuracy is around 20 nanoseconds and is caused by the initialization time that is necessary for starting the 7-stage pipeline. And at the beginning of the simulation, we set to a 6 nanosecond reset signal. So to sum up, we achieved the timing accuracy of a single clock cycle. The system structure can be adapted to application because the system is parameterized and number of cores and threads can be adjusted to the task and their time requirements. We avoid implementation of complicated memory arbitration method by using the extended thread interleaving method. So thank you for attention.
Thank you for presentation. So now it's time for discussion. We have a few minutes for questions, so please ask. If there are no questions, or maybe some, no questions. Okay, so we can go to the last presentation for this part of the session of SciFish session. This is a very interesting presentation which combines agricultural or producing of honey problem, very important problem of human beings, because one of the, I don't remember if it was Einstein or some other very famous guy who told that when bees die, the humans will survive only few years. So the problem is very interesting, combines two different areas of knowledge, the computer science or signal processing with problems of animals, so biological problems. So Mrs. Anna Wachowicz, who is the author of this presentation, are you present?
Yes, I am. I will now share the
So-
screen.
So now the screen is yours, and show us
Okay.
your very interesting topic.
Okay. Okay, so welcome everyone. My name is Anna Wachowicz. I'm a second year student of PhD at Salesian University of Technology. And today I will present you IoT monitoring systems in beekeeping. So the agenda of my presentation today is I will do the quick introduction and tell you some couple of words about the importance of bees in ecosystem, about colony collapse disorder, which is a phenomena that causes very large bee mortality all over the world. Then I will move to some history of beekeeping and present you existing solutions, IoT solutions for that area. And finally, I will present a proposal of IoT system for varroa detection and tell you some about some current results that I have and some further works that I will do in the future. And to end up the presentation, I will do the quick summary. So first of all, we all know how bees are important in our lives, but to give you some numbers, we should know that more than 1/3 of global food production is pollinated by insects, and bees are 2/3 of that number, so it's quite big. Apart from the food pollinators, bees also pollinate other plants like white flowers, and in Europe it's about 80%. So it's a huge amount of plants and trees and nature that we can admire every day. Apart from that, they provide biodiversity in whole ecosystem. And we should only also mention the economical effect of bees on our economy. And it's not only about honey and selling honey and all this branch of the trade, but we should also remember that food market is quite big all over the world, and it affects the food market and also the cosmetic market, because the pharmacy market, because nowadays we also use some bee products in cosmetical industry. So this is also important. And if we notice the bee mortality all over the world, then we have less honey, but also less plants that are pollinated, less flowers, and that also affects the whole economy. So they are important not only in ecosystem but in our lives also. We should always remember about it. As I mentioned before, we notice colony collapse disorder, the phenomena that is noticed for like 13 or even more years all over the world, not only in Europe, in Poland, but also in Canada, in USA, in Asia. We noticed that honeybees population is decreasing year by year, and we don't know the exact reasons why it happens. We have some possible reasons defined, And among that, we can tell about pesticides that are widely used in agriculture. We have some climate and environmental changes that cause bees, make them stressed and make them behave in different, not unwanted way. For example, they sometimes have some problems in with returning to apiary, to hive, so they just disappear, we can say so. On the other hand, we have some mites that affect the bees, like Varroa destructor, but also many other mites that makes them less healthy, makes them live shorter, so they can pollinate less plants. And also we have some malnutrition issues, because in winter, usually bees gather food before the winter, so during the winter they can stay alive. But sometimes beekeepers also need to give them extra food, so so they can survive, and this food may be also affected by some artificially modified or not proper prepared food, so it can also cause the troubles in bees' life. If it comes to history of bee monitoring, the first attempts were taken more than 100 years ago, and these were manual recordings of temperature and weight of beehive. And to be honest, this temperature and maybe humidity monitoring is now one of the most popular way of bee monitoring, because it's quite cheap and it provides many useful information for the beekeepers to assess if the condition of bees is good or bad. So it started more than 100 years ago, and in 1933, the first electrical thermocouple was used for bee monitoring. And then it's not the gap between the first use of electrical thermocouple and this 2008. It's not that none of the bee monitoring attempts were made, but along with technological advancement, there were some attempts made, but none of them were quite brand new. So the thing that happened in 2008 was the video recording for counting bees, and it was quite a huge event, because if we use video recording, we can do so many things. We can detect bees, we can count them, and we can also do many other image processing operations. Then 1 year after that, the sound analysis was made for the swarming detection. And again, it's quite important to know when the swarming process begins, so that the beekeeper can plan and prepare the place for new queen and the workers that will go with her, and prepare them a new hive, so they won't disappear, but they can stay in the apiary and extend the apiary. And in 2015, the precision beekeeping term was introduced, and it somehow started the IoT era in apiculture. And from that time, we can observe many maybe not so many, but examples of video and sound analysis, and also the temperature and environmental conditions in IoT systems in the Hypers. And currently, as for the IoT solutions for beekeeping, there are 5 types of the solutions. I already mentioned probably all of them. So it is visual monitoring systems. We have sound analysis. We have conditions that are inside and outside the hive. Usually it's temperature and the humidity. But there is also a solution that covers the analysis of other conditions, like, for example, carbon dioxide that is inside the hive. Also popular is weighting the hive, and it's important for 2 basic reasons. First of all, we know during the season of honey taking, let's say so, we know when there is enough amount of honey to be collected. And during winter, we know if bees have enough food to survive. So if the weight of the hive is too low, then the beekeepers know that the food is missing and they should provide some nutrition for the bees. And the last one is bee counting. It's also quite popular in current IoT solutions for beekeeping. So that was the introduction part. I hope for now it's clear for all why we should develop some such systems. And my proposal of an IoT system for varroa detection is quite, let's say, innovative, because we have two places where we use IoT devices. The first place is an IoT monitoring device that is placed near the entrance to the hive, and it monitors bees that are going inside and outside the hives. It gathers the data, and then it's transmitted to another IoT device, which is located not so far from this collecting device, but in safe place, not to distract the bees' work. So it will be located in the apiary, but not close to the hive, so bees can work without any distractions. Then we have local storage data, which is important if we operate on image data, because they just take much place for storing. And then we have IoT cloud, where the data from the devices will be transferred, and then the whole machine learning algorithm will be performed. We would have the notification for beekeepers if some bees will be detected as unhealthy, and we'll also store the data inside the cloud. So the architecture, the proposal of the architecture is as follows. And for now, the current results is that I created a prototype of the system that contains NVIDIA Jetson Nano computer with a WaveShare camera, which has quite good resolution, and power bank that supplies with the energy for the whole system. So it's just a part of the whole plant system, but it can already collect the data, and so the further works can proceed. And the data were collected during 2-day experimental trials that were taken in Piwniczna Zdrój in Poland. And these trials were taken with cooperation with Carpathians Beekeepers Association. And during these 2 days, we acquired more than 500 1-minute films with bees that are going inside and outside the hive, and we have quite good material to start the algorithms for bee detection, and then to detect the varroa existence on the bees. And now I will present you how the station for experiment looks like. So here we have the whole apiary. As you can see, there are many of beehives. And on the left, in the left picture, you can see 2 gray boxes. The smallest one is the camera that collects the data, and inside this bigger one, we have Jetson Nano computer with power bank. And here we have some data, some picture of bees that are gathering around the entrance of the beehive. And now I will present you 2 attempts of the monitoring. So this is from the first day. As you can see, it's not so, the image is not so shaped. And but you can see the bees, and they are visible. So we can say that we see the bees. And during the second day, when the camera was adjusted, we can see them clearer, and all the details on the bees are also seen. So it gives just great start for further analysis, for future analysis of image and for varroa detection. So further works will contain bee recognition, varroa recognition. And as you can see in this picture, varroa is this is a mite that is placed on the bee body. It's quite big, and it's red or brown sometimes. So it will be, it should be easy to be detected with this algorithms that will be applied. Then I will think of prototype extension and to create some coverages for the prototypes so they can survive with various conditions, weather conditions. Then there is cloud implementation to be done, and of course I will need even more data with affected bees to perform this varroa recognition thing. And to sum up everything, as we know, the bees are very, very important. There are many ways of bee monitoring, but when we compare the solutions for the IoT solutions for beekeeping, you can notice that it's not so popular as other IoT solutions for agriculture or other things. And yeah, and I also presented you the existing prototype that will be extended in the future, and that's all from my side. So thank you for your attention, and if you have any questions, please do not hesitate to ask.
Thank you for very interesting presentation. So now it's time for questions.
Hello, I have one question. Monika Nysz from the
Yeah.
Have you taken into account the costs of the cloud services for long time monitoring?
No, I haven't thought about it now.
Because this could be a very serious issue in case of long time monitoring.
Yeah, I should probably think about it. We thought that maybe we will look for some free
Mhm.
clouds, but I haven't thought about the details of it right now. But thank you for the tip. I should definitely take it into account.
Thank you.
Yes,
Okay.
hello.
Yes, please.
Yes, I have a question. What is the communication from the camera to the edge device? What kind of communication have you
Between
considered?
this is the problematic part actually, because bees are quite sensitive to radioactive radio waves. So existing protocols may distract bees. And I thought that maybe between the first and the second IoT devices, there will be just a cable connection that will go, because the apiary itself, it's not quite big that there cannot be some cable connections. And then from the central point of the second IoT device, then the data can be transferred via the internet or other Wi-Fi or any other protocol. But from the Beehive devices, I would like it to be a cable connection.
Yeah, but another question is that the data that you are connecting is the images, right?
Yeah.
Are you going to send the images to the cloud, or you are going to process and send just some features?
Partially, they will be processed on the second device, and partially they will be sent to the cloud.
Yeah, because one of the key things is that very certain the communication from the edge device that is at the bee farm to the one at the cloud will surely be wireless. And so the bandwidth will be another issue, and the energy consumption will be another issue. So maybe I don't know if the image processing algorithms that you are running on the edge, the first is that maybe they could extract some features and don't send the whole image, because when you're sending the whole image, you will increase the cost of the bandwidth because the internet is not free, and also the cost of the energy consumption.
Yeah, that's nice.
Mm-hmm.
Tip.
And also the algorithms that you are running on that edge device, you should also consider the trade-off between the energy consumption of the algorithms and the performance of the algorithms.
Definitely. But if it comes to the power consumption on this the second IoT device, it's not it will be not the key issue, because here I'm not I can use some bigger solutions for power supply.
Yeah,
I'm not,
but the question is that does your bee farm is connected to the grid, or you are supposed to be using renewable energy, because it depends on your energy source?
Yeah.
Okay, it's okay. Thank you so much. But
Thank you.
Take into consideration the energy consumption and the cost of the connection. These two are very important.
I will definitely do that.
Okay.
Okay, have you got more questions? If not, thank you once again for the very interesting presentation. And now we
Thank
have
you.
a short break, 10 minutes for recovering. So thank you very much for attendance.
Thank you, Professor, for chairing this session. Okay, ladies and gentlemen, we start the next session, the second part of the special session, Cyber Physical Systems. The chairwoman in this case is Anna Kamińska-Hufmała from Wrocław University of Science and Technology from Poland. Dear professor, the session is yours.
Thank you, Piotr. Right, I think too that we can start. Good afternoon, everyone. I would like to welcome you at this special session about physics. You can see from the program that we have 4 presentations. So I would like to remind for all participants that we have more or less 15 minutes for the presentations and about 5 minutes allocated for questions at the end. Okay, now let's move on to the first speaker. I'm delighted to introduce Mr. Piotr Grzesik, who will tell us something about evolution of Apache agent from stream analytics at the edge. So please, Mr. Grzesik, the scene is yours.
Thank you for the introduction. Welcome everyone. I will now try to share my screen with the presentation. Let me find it. Okay, now it should be sharing. So once again, thank you everyone for coming to my presentation. I would like to present my short research on Apache Agent. I will present the evaluation of Apache Agent for stream analytics at the edge. My name is Piotr Grzesik, and I'm a PhD candidate at Silesian University of Technology, currently on my 2nd year. Let's move to the agenda. So at the beginning, I will briefly mention the IoT applications and why they are important and how they are growing at the moment. After that, I will mention the benefits of processing data at the edge. In the previous presentations, we already had some examples of that happening. In the next step, I will briefly mention the edge devices that I was considering for this research. After that, I will mention what is the actual goal of the research of the presented works. Brief mention of related works, and I will move on to selected technologies, description and implementation of the whole system, and the performance, CPU, and memory consumption tests that were carried out during the experiments. So let's start with the IoT applications. They are getting more and more attention, and they are getting more popular in a lot of different use cases. They are used for environmental monitoring, for telemedicine, for healthcare. They are underpinning the smart cities, smart homes, smart cars, agriculture and farming, and many, many more. However, there is one issue that is becoming a bigger problem, which is the sheer volume of data that are generated by the IoT applications. Very often they are used in places with like spotty internet connection, so it's very hard to send them to cloud and process them there. In order to address that problem, the new computing paradigm emerged a few years ago, which is called edge computing, that brings the data processing and storage closer to a place where the data is needed or is generated. So, for example, if we are processing data, we are monitoring bees, we can process that data directly at the edge device before sending that to the cloud, following the previous presentation example. The additional benefit is that it allows to improve reaction time to the changing state of the system. So, for example, if we are building an autonomous car, it would be pretty challenging to send all of the data to the cloud, wait for processing, and react in real time. That's why we want to move that to the edge and process data at the edge. And as I already mentioned, it also improves resilience in case where the internet connection is not reliable or not available at all in most times. There is no strict definition of an edge device, really. It's basically any device, any processing device, computing device that is close to the source of the data. In my case, I was focusing mostly on single board computers that are not like low powered, not very expensive. All of them are cost less than $100 or $150. In my particular case, I focused on Raspberry Pi because it has a very good support and it's very widely used for multiple use cases, and it's also very comparatively cheap. So the main goal of the research is to evaluate how we can process the stream of data, because the data that is produced by IoT devices is often in a form of a stream, like a stream of readings, stream of data points. And one of the stream analytics engines is called Apache Agent, which is aimed at applications that are running at the edge, so for low-powered devices. And I wanted to evaluate this in a context of a stream processing application that is running on a low-cost constrained edge device, in this case Raspberry Pi, that is processing data from air quality sensors in this particular case. To briefly mention related works, as we don't have a lot of time, I will just mention that I couldn't find a lot of examples of actually taking advantage of Apache Agent. I found quite a few examples of processing at the edge, stream processing at the edge. However, in most cases, they were focusing on like bigger frameworks, bigger deployments on not low-powered devices, but very often they were using like full-blown servers for high performance processing at the edge. I was trying to focus on smaller, cheap devices that are running Apache Agent specifically. When it comes to selected technologies, the most important one is the Apache Agent, which is a framework, open source framework written in Java, a programming language. It's both a programming model and a runtime that allows us to implement and support stream processing applications. It's aimed at edge devices, but it can be run even in the cloud as well. It supports multiple stream-based operations, for example, filtering, splitting streams of data, transforming it, windowing function, various aggregations. So it's possible to process data in various ways. The other important protocol that was used is MQTT, which is a very common, very widely used open source lightweight messaging protocol dedicated for communication in IoT based systems. The particular implementation of a broker that was supporting MQTT protocol that I chose was Mosquitto. It's written in C programming language. It's currently maintained by Eclipse Foundation. It was designed to be lightweight, performant, and it's very easy to deploy it even on like single boards, on single board computers such as Raspberry Pi. So it's just also like very popular, very widely spread, very easy to use, and very easy to deploy on even on low-powered devices. And the last piece of hardware in this case is Raspberry Pi, which is a small single-board computer that I also mentioned previously. And the particular version of Raspberry Pi that was used during the experiment is the Raspberry Pi 4 with 4 gigabytes of memory. As we will see later, we could use even less powerful device in this particular case. So let's move to the testing environment that I built and used for testing. So it has 3 pieces. The central piece of the whole solution, of the whole implementation, is the edge device, which is the Raspberry Pi that runs basically, in addition to the operating system, it runs 2 different applications. One of them is the Mosquitto broker, which serves as a MQTT broker. And the other one is the Apache Agent application, which serves both as a subscriber and a publisher to the broker. I will dive into more details in just a minute. The other part of the testing environment is a sensor network, which is a 6LoWPAN sensor network that communicates with the edge device by just publishing messages to a message broker thanks to MQTT protocol. And the third part, not really highlighted in this particular presentation, is the cloud side, which is a subscriber to the streams on the edge device. It also can be diverted. The other broker can also run in the cloud, and we can publish messages there, which is supposed to react to the alerts that are generated and are published by the edge device analytics. So just additional summary, the 6LoWPAN based sensor network was responsible for collecting measurements such as air quality metrics and weather condition metrics and sending them to a message broker. Edge device is both a message broker and analytical engine. Cloud-based service is for further data processing for notifications. And to simplify and to allow for quicker iterations during testing, in addition to that, I also implemented a sensor reading generator that was running on a separate Raspberry Pi that was used to emulate the sensor networks, because it was just easier to test it in multiple scenarios, multiple times in a short span of time. And the generator was written in Python programming language. The readings data model that was used was represented in form of JSON data points, essentially, which stored 3 different air quality metrics. And in addition, the sensor ID and location. It also recorded the temperature that was just pruned from the messages because it wasn't used in this particular case. And here we can see the example reading used for the performance experiments. So it's just a plain JSON formatted string. Here on this slide, we can see the analytical engine that was implemented, or rather the flow of the processing that was implemented as a part of Apache Agent application. So at the beginning, the application is subscribing for sensor readings on the MQTT topic. Later, the operation on the message stream converts the string messages that were read from the topic to JSON stream. Then the application splits that stream into 3 separate streams for each specific type of value that we are measuring. In the next step, the value is averaged for the last minute. So for the last 60 seconds with a windowing function. And after that, we are filtering the values on each stream against a predefined threshold that signifies that it is a warning, like it is an alert because the value that we are getting is too high. And in a response to that, the warnings are published to another MQTT topics that later the cloud-based system can subscribe to and to process that further. So that was implemented as a part of Apache Agent application. And having all of that implemented, I wanted to evaluate how performant that solution even is. Like how much data can it support? Like how big volume of data it can support on such a small device as Raspberry Pi. So during the tests, I conducted experiments for a few frequencies of data generation. So I set up the other device, other Raspberry Pi with that, and generated data with frequencies of 5 to 500 hertz, generating 500 readings per second. And for each frequency, both percentage load per CPU core as well as average memory consumptions were recorded. For CPU load, I was using the CPU stat. It was configured to record CPU utilization every second, and it was later averaged per minute. And it was done in a similar way for memory using VMstat. I was running that experiments multiple times. It was like 50 times, I believe, or around 50 times for each of the simulations, and averaged the results. And the results that I obtained was that we see a clear correlation of the frequency of the readings that we are processing with this average CPU load percentage. For the 500 Hertz, it was over 50%. However, when going above that range, like 550 or 600 Hertz, the application was no longer able to process all of the data in real time. So that's why the cutoff at 500 Hertz. And for memory, it actually turned out that there is very little difference. Like the differences were like 5 to 10 megabytes extra memory used when processing data with higher frequencies, which means that even the Raspberry Pi with like 1 gigabyte of memory would be sufficient for this particular use case. In the short summary, to reiterate, like the average CPU load heavily depends on the volume of the incoming data, and it was determined during the experiments that the application is able, in this particular use case, is able to process 500 readings per second in real time using this Apache Agent flow implemented, recording an average 54% of CPU load. However, when processing more than 500 readings, while there were runs when it was possible to process everything in real time, there were multiple situations where the application was just not able to keep up with the data that was generated. And as for memory, we don't really see a correlation. It's just a very small increase in memory consumption when we go from 5 to 500 Hertz scenario. And for the next steps, I want to test also with more complex stream processing operations and different use cases for that, and also test with Android devices. And also, I want to test how well Apache Agent is able to scale, because it's possible to have a multi-device deployment. And that's all from me for today. Thank you for your attention.
Thank you for presentation. I'm sure that after the stimulating presentation, you would like to ask some questions or comment on some of the points the speaker made. If not, I would like to ask you one question, because I'm interested what period of time was taking your experiment?
Are you asking about the whole experiment to prepare the whole research, or specific use case?
No, the whole experiment. How long was taken? How long was this period of the time was taking the whole experiment?
It was around a few weeks. I actually kind of reused the setup that I had for the other experiment when I already had the 6LoWPAN network running. That was taking a longer time if I would take that into the account. For this, it was probably like a few weeks of testing, and later running, like when having everything set up ready, then just running extra test was not so time consuming anymore.
Okay, thank you. And how long was taking this experiment? Half year ago, 1 year ago?
It was this year, at the beginning of this year.
So it's quite fresh.
Yeah, that's true.
Oh. Okay, thank you. Do you have maybe any other questions? If not, so thank you once again for your presentations. And now we have time to the next presentation. So now I would like to hand over to you, Mr. Marcin Karcz, who will be present people evacuation system based on the ZigBee network. So please, Mr. Marcin Karcz, the scene is yours.
Do you hear me?
Yes, we hear.
Okay. Okay. Hello, everybody. My name is Marcin Karcz, and I want to show you my presentation about ZigBee network in development of evacuation system in mines. Yeah? In the start, I want to say something about ZigBee network. Next, I want to say something about use of ZigBee network in mines.
Sorry to interrupt you, but you can share with us your presentation. Could you share your presentation?
Okay, moment.
Because we don't see the slides.
Give me a moment. Screen.
Yeah, now we see.
Now, better?
Okay, yes, now we see the slides. Thank you.
So one more time, I want to, in the start, I want to say something about ZigBee network. Next, I want to say something about the use of ZigBee network in mines, and in the finish, our proposed system. So the ZigBee network was founded in 2002 as a non-profit organization. And it opened the new members wanting to develop into the product. The ZigBee standard used the IEEE 802.50.4 protocol as the physical layer protocol, and access control protocols, which means that the device that comply with the ZigBee standard and compliant with the IEEE 802.50.4 standard. The use of wireless communication to collect information or perform curtain control tasks at home or industrial premise is generally known, applies to short range wireless network, including IEEE 802.11 wireless LAN, and also Bluetooth. The IEEE 802.50.4 communication standard is dedicated to monitoring, building automation, measuring meter readings, defines a set of communication protocols for low data rates of short-range wireless networks. The wireless device compliant with the IEEE 802.50.4 standard operate in the following frequency bands, like 868 megahertz, 915 megahertz, and 2.4 gigahertz. And I have the data transfer rates up to 250 kilobytes per second. The ZigBee is directly mainly the device with battery backup, where it's required for low data transmission rate and the relatively long power supply time. ZigBee use the following types of device. The first is most important is coordinator. The device initiates and controls the operation of the network, save information about the network, also functioning as an authentical element, storing the security key. Next is a router. Router is enabling dynamic routing, which allows you to maintain communication also in the event of damage, reconfiguration or shutdown of part of the network, and can combine coordination device, ordinary device, and device with limited functionality. The last device is the int element with the limited functionality. They receive and send information, but do not have any routing capabilities. These are usually simple sensor, which are also ISD and device. The ZigBee standard defined by the IEEE 802.50.4 physical layer and access control protocols. The MAC supplier controls access to the radio channel using the CSMA CA collision avoidance method. And this layer can be responsible for sending information frames, synchronization, and providing a reliable transmission mechanism. The network topology is determined at the network layer level and can be the star, the tree, or lattice type. The first, the star, and this network is controlled through a single device, and all other interface called terminal device communicate with this directly. In the case of tree and the lattice topology, the coordinating device is only responsible for starting the network and defining key parameters. The wireless communication standard IEEE 802.50.4 is great advantage because it does not require cabling, and in mining condition we gain not only the reduction of cost due to the lack of cable cost, but also avoid man failures that we observe in current mine network, because in small dimension of excavitation, mining cables often cause damage during transport and going work. Yeah. Our proposal of system consists of the network of densely spaced device covering all mine, giving the system manager a tool to monitor the condition in the mine and possibility of immediate response to the emergency of trade to people staying in the mine, maze of corridors. The device consists of several modules. The first is measuring module that collects information about the condition around the device. With the help of the data archiving system at the system service stand, it will be possible to analyze change in parameters over the time, which will allow to catch change in individual place of the system and allow undertaking action and preventing a trade situation. Yeah. The wireless device based on the ZigBee protocol can be used to measure the environmental parameters and the sensor location. This multi-parameter sensor module can collect up to 8 types of environmental data that are sent to the processor module, and the processor module filters and amplifies, converts to the signal that processed data are displayed on the display and compared with the set safety threshold. If the level of the tested parameter is exceeded and audible, the visual alarm is triggered. At the same time, the wireless communication module transmits data to the ground computer via the backbone network, where measurements are ready to be a supervisor in the visualization system. Yeah. The device consists several modules. The first is measuring module that collect the information about the condition and in around of the device. The measuring module consists of the following sensor, like temperature sensor, humidity sensor, CO2 sensor, also a CH4 sensor, which give information about the condition in individual place of the mine. Successfully appearing device give a wide picture of the situation in the mine. Next module is the light and the sound system, which has the task to give the direction of evacuation to people staying near the device. The module is started when a threat is detected or activated by the system supervisor. In specific case, the device generates successfully a light and sound signal. And the close distance of the device allows one to force the direction of evacuation for people nearby. The network of the device located in all corridors of the mine allows the entire crowd to be led to the evacuation site. Directing the employees' evacuation route individually from the location in the location of the search for danger. The last module is communication system using the ZigBee module. It's a responsibility for the exchange of network packets between individual devices in the network and transfer to the coordinate. Our algorithm of the device operation is based on the transmission of information collected by the sensors to the coordinator and temporary sleep to save power supply. In normal operation, when the measuring system does not register the exceeding of threshold values of the analyzed parameters, the device will be sleep state for a specific time, and the system manager may shorten the sleep time in the event of any increase in one of the parameters to the level specified by the user, and download more frequent updates for selected bench. Reaction time for delivery date is sleeping in end device are about 100 milliseconds, but it's unnecessary in this functionality. Device is waking up periodically, transmit data to coordinator, and receive that if they were transmitted. ZigBee standard does not provide sleeping option for routers, which should be in non-sleeping mode all the time. But there is an option in some proprietary ZigBee type solution, DigiMesh network, which provides sleeping configuration for even old nodes in the network. In the event of an emergency team, the system manager activates the light and sound system to bring employees to safe place, determining the location of safe place and designating and the generate place to direct to the evacuation, bypassing the dangerous area. The system has predefined routers of evacuation for many scenarios and different localization of the any accidents like fire or smoke. The system manager also collects information from sensor and other sources online and has ability to select a predefined scenario or dynamically select the, or change evacuation routes individually for every tunnel accordingly the changing emergency situation. People-to-people emergency communication through the chain of ZigBee nodes is rated not widely implemented in ZigBee systems. It could be realized using text terminals, but these solutions are not popular. There are several solutions when a rescue group can leave the ZigBee nodes behind wide moving row galleries for providing communication with rescue center. Reliably, transmission of network packets are provided by routing protocols with self-heading property. Dense placing nodes within their radar range and acknowledge packets. Conclusion, the create of a reliability tool that allows monitoring of the condition through the network of mine corridors or large shopping malls with the simultaneous possibility of using the system to carry out an efficient evacuation in real time can significantly improve the safety of people staying in the facility. A simple protocol, low implementation price, and trouble-free system make it possibility to consult the ZigBee standard in the site to the construction of an evacuation system consisting of a densely arranged device whose task is to direct to the evacuation route of all persons staying in the facility depending on the place of danger. That will be all. Thank you for your attention.
Thank you for your presentation. And maybe would you like to ask some questions for Mr. Karcz? It's really interesting presentations of this topic. If no, I would like to ask some question because you presented some example on the mine building, and could you tell me that you're taking into account some concrete mine in Poland or somewhere else, or it's just exemplary? It's not.
No, this is exemplar.
Exemplar, yes. Okay,
yeah.
so
this system could be used on every one mine. Yeah.
Okay, so it wasn't based on such concrete mine, yes?
No.
Okay, thank you. Maybe any other question? Okay, if not, so thank you once again for your presentation.
Thank you.
And now we can go to the next presentation, the third one. So it's my pleasure to introduce you the next speaker, Mr. Ireneusz Smoka, I suppose, and Jacek Stój. I suppose that Mr. Ireneusz Smoka will be presenting, yes?
Yes.
Okay, so today Mr. Smoka will be speak on the use of software-defined networks for process data extraction, proof of concept. So please, the scene is yours.
Okay. Do you see my presentation?
Yes, I see the slides.
Okay. Good afternoon, everybody. I would like to tell you some information. Okay. Information about SDN, a software-defined network. And about work my colleague Jacek Stój. Something information about my presentation. I would like to say answer about a few questions. What is software defined network? Why we use Open Daylight for our simulation, how we tested our solution, and why we use Modbus TCP for test. And the last question: what we would like to do in the future with SDN. First, software-defined network. What is this? It's solution to separate layer in a network, application layer from control layer, from infrastructure layer, and we can control. Our network from remote controller, from different device or from different application started on another computer, on another machine like embedded devices. In software-defined network, we can directly programmable how our flow, how our switch work, from which port from which source port we can transmit our information to which destination port we can transmit information. And in traditional network, the control plane, data plane is in a switch, yes. But in software-defined network, we can controller, SDN controller, and SDN switch, which communicate with SDN controller through OpenFlow protocol and adjust flow parameters in flow table to parameters generated in our application and program which we created, or we can get parameters from business application, or for example HMI application, probably in control systems in industry. OpenFlow protocol and flow table. What we can do with OpenFlow protocol? We can forward packets from source IP to destination IP, but it's not like in a traditional work. We can dynamically manage, for example, destination IP, yes, when we would like transmit information from source IP with the end of 100 for every 10 transactions, we could program create our program that we can do it. In the flow table, we can define what the switch do in a normal work when our program is not work correctly. When we can when we haven't got connection between SDN controller and our switch, everything is defined in flow protocol, OpenFlow protocol, and everything and every fields of OpenFlow protocol. Why we use Open Daylight? In our work with Open Daylight software, we use Open Daylight because this software has a lot of plugins to observe SDN network, to connect different remote SDN controllers, but Open Daylight is a type of SDN controller, and when we install a plugin, our our software Open Daylight could be a remote controller for our switch. Open Daylight, in my case, work with Mininet, which is installed in Ubuntu, in virtual machine with Ubuntu. We tested a few topology batch for our test our solution. We use single topology with one switch, 3 hosts, remote controller with simply MAC address. It's option MAC define MAC address as very simple number, and we use OFS switch to switch connection between our hosts. Testbed. In our testbed, we had got virtual machine with Mininet, different virtual machine with Open Daylight, which are connected to real network, to real infrastructure, but through NAT connection. And real network, we had got a PLC, a PC computer, and SDN switch. SDN switch is a MikroTik TLS 326 with OpenFlow plugin. Okay, what we did it. We prepare program which send packets between one host, which from Modbus TCP server to Modbus TCP client, but not only to Modbus TCP client, and also to data extraction device, which storage our information from Modbus TCP server, and use for different other works, like prepare new value for control parameter, like prepare visualization, like prepare information for IoT devices for industrial Internet of Things. Our solution could send information between the client and the server, and duplicate information and send to another device, data extraction device. In my case, the data extraction device is a Raspberry Pi or BeagleBone Black, which is simply to programming and simply to get data from SDN switch. Why we use Modbus TCP? We used Modbus TCP because it's easy to connect to different type of devices. It's quite old protocol, and it's easy to implementation in devices like Arduino, like Raspberry Pi, but in Google Play Store, we have application which simulate information, information like Modbus TCP server, and we can send information to our network from private smartphone. Modbus TCP could simulate on a PC computer. In the network, we can a lot of programs which simulate that device and send our information, our data to test our solution. How we could define the flow? The first way we can define OVS in Mininet. We can OVS switch define flow from and switch S1 and port 2. As actions, we define output free from switch, and Ethernet type, DL type, we define EtherCAT. 0xx88A4 is EtherCAT, and every transmission in port from port 2 to output to port 3, we transmit only EtherCAT. And the second type, 0x8892, from port second, we transmit only Profinet protocol to output 3. The second way, we define a port which we transmit to in our switch from port 1 to output 3. Every from port 502 we transmit to at destination address IP, and we could define a few cases where we define another output port, another device to transmit data. Where our solution would work and control systems integrated with Internet of Things, and in control system which use redundant devices. We can transmit information from one devices to few different PLC, for example, from PLC and control, and get control from one PLC and from primary PLC and get control permission tag for secondary PLC. Future works. In future, we could we would like to do testbeds with real controller implements in embedded device. Probably it will be Raspberry Pi or BeagleBone Black, because it's in Raspberry Pi we could find Linux distribution, and it's easier than another devices like NVIDIA Jetson Nano, for example. And making it, we would like make measurements with model of industrial installation and connecting our solution to the system which could process the receive data. Thank you for your attention, and I'm waiting for the question.
Thank you very much. Could you have any questions? Because as I saw that there existed very interesting discuss on the group chat about OS, what kind is the best one. So maybe would you like to say something and ask Mr. Smoka about some experience?
I think in our cases, when we prepared a virtual machine, Ubuntu operation system is the best option for us because this distribution is easy to use. Everything is simply, and we don't lose time to configure more complicated distribution, more complicated operation system.
Yes, thank you. And maybe someone would like to ask some question also to Mr. Smoka. So thank you again for your interesting presentation, and I keep fingers for your next future plans for testbed and apply this experiment in real future. So I wish you good luck with that, and thank you very much. And now let's go to the last presentation which we left. So the authors are Mr. Mateusz Kuc, Wojciech Sułek, and Dariusz Kania. The paper is about power consumption in QCL-DPC decoders. And I suppose Mr. Sułek will be made presentation. That's right? I'm correct?
Yes, thank you, Mr. Professor.
So thank you. Yes, and we see the presentation, but could you only get full screen control? Yes, it will be great. So thank you.
Okay, thank you. So, ladies and gentlemen, the article that we submitted to this conference presents the results of implementation of LDPC decoder in an FPGA device that has been done in cooperation with our PhD student Mateusz Kuc. So actually he is the main author of this paper, but unfortunately he could not attend this meeting, so I will present briefly the outcome of this research work instead of him. So this presentation was prepared by him, but I will present it shortly. Mateusz, together with me and also with Professor Dariusz Kania, develops an implementation of the decoder that is intended to be energy efficient. It means that he tries to optimize the decoder construction in order to achieve a significantly significant energy consumption reduction in comparison with other classical known implementations. This is actually a kind of work in progress. So, and this article submitted to this conference present an experimental results that have been obtained for the decoder that has been already implemented, but it is still developed. These results presented here include the energy consumption estimation that has been achieved with the use of the software by the Intel, software that is for FPGA devices, for example, of the Cyclone family that we use. And on the other hand, we also present the results for the bit error rates estimation achieved experimentally for the selected LDPC codes in the system that we develop. So for the introduction, what are actually the LDPC codes? So these are a class of linear block codes used for error correction. So in the short ECC, which means error correction coding. It is used for detection and correction of data corruption that appears mainly in the wireless communication systems, but also in other technology areas like in the dense digital data storage systems, for example, NAND flash memories or other storage systems. In order to protect the data from the corruption, the data stream is typically filled with additional data, referred as the parity bits or redundant bits. And in the case of block coding, the data stream should be partitioned into blocks or bit vectors, referred to as source vectors and code vectors. In the encoding process, every source vector is expanded with some number of parity symbols into a code word of a particular code. Of course, these parity symbols provide the error correction capabilities. In the case of binary codes, the source vector and the code vector elements are binary symbols or zeros and ones. And the decoding process, very briefly speaking, is realized by finding the most probable vector satisfying the specific equation called parity check equation, which is in the form of matrix multiplication with arithmetic operations over Galois field of the order of 2. However, this is just a simple idea of the decoding, because in fact finding such a most probable vector that satisfies this equation is a quite difficult task for a large codes, and this process of decoding is done according to a specific algorithm that is typically quite complicated. In this equation, the matrix H is called parity check matrix, and it defines the parity checks specific for the particular code, and only vectors satisfying parity check equations are valid code vectors. So actually, the parity check matrix defines a particular code. And LDPC codes, particularly, are a class of linear block codes with a characteristic that a parity check matrix has low density. The parity check matrix has a low density of non-zero elements. This is a quite simplified definition of the LDPC code. Besides the parity check matrix representation, every code can be also alternatively represented by its associated code graph. An example is shown in this slide. This graph is also known as Tanner graph, and it corresponds directly to the parity check matrix. Every row of the parity check matrix define a single equation over a Galois field, And the non-zero elements are the coefficients of the check equations. And on the Tanner graph contains two types of nodes: variable nodes, denoted here by circles, which are also associated with parity check matrix columns, and check nodes associated with parity check matrix rows. Here are denoted by squares. And edges in the graph corresponds to non-zero elements of the parity check matrix. This example here presented are quite simple because codes used in practice are obviously of the much greater code word length. So the graph is also much greater. But for this simple example, I used a very small matrix for a very short code word. Such codes are not used in practice, but this is just for illustration here. Today, LDPC codes are probably the most extensively used methods for error correction in advanced industrial wireless digital communication systems. LDPC codes have been applied in all standards listed on this slide, like in Wi-Fi, in digital video broadcasting standards, recently also in the fifth generation mobile communication system. But still, the implementation of LDPC codecs is still quite a challenging task, and this motivates the research in this area of efficient and energy efficient LDPC codecs implementation. Most of the LDPC codes applied in the practical systems belong to the specific class of the quasi-cyclic LDPC or QC LDPC codes, in which class the parity check matrix is partitioned into square sub-blocks, with each subblock being either an all-zero matrix or a cyclical shift of columns of the identity matrix. It means such a cyclical shift contains exactly one non-zero element in every row and in every column of the submatrix. The submatrix size here is denoted as P. The QC LDPC structure is well suited to the hardware implementations. An efficient parallel implementation of any message passing decoding algorithm calls for the parity check matrix to be structured in this way. So this is why we actually interested in mostly in the QC LDPC codes. The classical LDPC decoding operates in a kind of loop. An example is shown in this slide. In this loop, in every iteration, as a matrix known as beliefs are updated. These beliefs are denoted here by R and Q letters. A belief is actually an estimation of the probability that a bit of a code word is 1 or 0, respectively. And on the other hand, there are also beliefs that a particular parity check equations are satisfied. This concept of beliefs is also visualized by a Tanner graph, and so we can say that about variable node beliefs and check node beliefs from the Tanner graph point of view. And the algorithm approximates iteratively these beliefs or approximations of probabilities, and after every loop iteration, the algorithm obtains more accurate beliefs about the bits in the code word. If after some iteration the parity check equation is satisfied, so all the parities are satisfied with a given belief distribution, with the belief distribution that has been obtained in this iteration, then the decoding can be halted and obtained hard decisions or bits basing on the beliefs are the algorithm output. So this is an algorithm that is called belief propagation algorithm, And the slide actually illustrates one of the classic belief propagation algorithms known as min-sum algorithm. So the min-sum algorithm is one of the classic belief propagation algorithms, but there are more algorithms. However, I will not mention it now. So basing on this classic decoding algorithm, an implementation in FPGA device has been developed by our PhD student Mateusz Kuc. And the main part of the decoder are the computation units that recalculates the beliefs in an iterative process. And these beliefs are stored in appropriate memories, and they are stored in a representation, in a compressed representation of fixed point numbers with precision reduced to just a few bits. This decoder is actually semi-parallel. It's a semi-parallel architecture, which means that the iterative process is performed by a number of computation units, and these units operate in parallel, but the number of units is significantly lower than the number of nodes in the Tanner graph, which means actually in every iteration, the process has to be done sequentially. So every iteration is actually partitioned into a number of sub-iterations in which the iteration is performed. The decoder implements the min-sum algorithm, but it can also be configured to a few modifications of this algorithm, particularly to the normalized min-sum algorithm, which is known to improve the decoding effectiveness. The decoder chip also includes some other generators, control units, and other modules that are necessary for the decoding operation. A few another configurations of the decoder are possible, particularly the number of computing units is configurable. Of course, if the implementation contains more computing units, the decoder is finished in a shorter time period, but the power consumption of the decoder is proportionally higher. With lower number of computing units, the power consumption is lower, but the decoding is finished after longer time period. However, the total energy consumption, which can be roughly calculated as a product of the time period of the decoding and the power consumption, could be similar in this example 3 configurations shown in this slide. However, this is not always the case because of the specific construction of the decoder and the method of configuration of the decoder hardware. So a part of this work was to assess the unit energy used by the developed decoder implementation. We define this unit energy to be average dynamic energy consumed by an FPGA device per decoded bit. So we actually normalized the total energy used by the decoding of a single block to the number of bits in this block, and obtaining the average dynamic energy per decoded bit. So it is normalized per decoded bit. So let me go to these experimental results that we obtained with this implemented decoder. The energy consumption has been estimated making use of the software from the Intel for the Cyclone 5 family of the FPGA devices. And in this first table, we present the obtained energy consumption for 5 different configurations of the decoding algorithm, specifically for the min-sum algorithm that I mentioned, and also the normalized min-sum algorithm. So NMS, it's a normalized min-sum algorithm with different normalization factors denoted here by letter A. And it can be seen that the application of the different normalizations, different parameters A, in the normalized min-sum algorithm increases the hardware limit by only approximately 1%, so it is negligible. Also, the use of the NMS algorithm does not change the number of clock signal cycles needed to perform one iteration of the decoding. It can be also observed that normalized mean-sum variance increase the average dynamic power consumption and the average dynamic energy per bit of the decoding vector by approximately 9% in comparison with the mean-sum algorithm. The use of the normalized mean-sum algorithm does not change the number of clock signals needed to perform one iteration of the algorithm. On the other hand, the normalized mean-sum algorithm have better correction performance, which is expressed here by bit error and frame error curves. So in this chart, BER, so it means bit error rate, and FER, frame error rate curves are presented in the function of signal to noise ratio in the binary AWGN channel. It means that for these results, a system simulation has been employed with communications link operated with binary modulation or BPSK modulation, and the modulated signal has been simulated to be transmitted over additive wide Gaussian noise channel, and decoding with the real decoder operated in the FPGA chip. So the simulation environment is a mix of software models and the implemented hardware decoder. And we can observe that normalized mean-sum decoder is better from the point of view of bit error rate curves than the original mean-sum algorithm. The next table presents the impact of the data bus on the precision of the fixed point representation. The average dynamic power consumption and the average dynamic energy per bit of the decoding vector increased by approximately 30% for the 5-bit bus relative to the 4-bit bus. So this means that the use of a 5-bit bus is quite not justified for this case. On the other hand, we can observe an improvement in the bit error rate compared to the 4-bit bus, but the improvement cannot be considered as very significant. And finally, the table presenting the influence of the submatrix size, P. We can see that as the size of the submatrix of the QC LDPC parity check matrix increases, and the hardware demand for the adaptive logic modules, so the ALM modules, its adaptive logic modules they are the main modules of the FPGA device, increases, and the number of memory bits required decreases. We can also observe that as the size of P matrix increases, the number of clock cycles needed to perform one iteration of the decoding algorithm decreases. So with the increase of the submatrix size, the average dynamic power consumption increases, but the average dynamic energy needed to decode 1 bit of the vector decreases. This means that systems with larger submatrix size P consume more power, but they are actually more energy efficient. The calculations are faster, and the total energy consumed by the system is smaller. If there is a need to reduce dynamic power consumption per unit of time, smaller submatrices will be probably recommended. And for smallest submatrix sizes, P, the bit error rate parameters are slightly better, as can be seen in these results. So conclusions: normalized mean-sum variance increased the average dynamic power consumption of the implemented decoder and the average dynamic energy per bit of the decoded vector by approximately 9%. The average dynamic power consumption and the average dynamic energy per bit of the decoded vector increased by approximately 30% for the 5-bit bus relative to the 4-bit bus. This means that the use of 5-bit bus is not justified because the improving of BER is quite insignificant. With the increase of the size of the P matrices, the average dynamic power consumption increases and the average dynamic energy needed to decode 1 bit of the vector decreases. This means that systems with a larger matrix, submatrix size are more energy efficient the calculations are faster and the total energy consumed by the system is smaller. If there is a need to reduce dynamic power consumption per unit of time, smaller submatrices of the parity check matrix will probably be better, as is indicated by these results that we presented. And thank you for attention.
Thank you very much for your presentation. And maybe someone, would you like to ask some questions about this interesting presentation? So please feel free. Okay, so if there are no questions, I would like to ask one question, because it was interesting presentation, many algorithms like mean sum or normalized mean sum with different parameters. So could you tell me if you could if you have to choose the optimal version of algorithm for all of this, it could be the best one for all, for power consumption, for decoded bit per code word. What, because in some cases there are different better. So in your opinion, the optimal would be the most sufficient for all cases, will be the best one. What kind of algorithm it could be, for, in your opinion?
So in my opinion, from these algorithms that were considered in this work, I would choose the normalized mean sum algorithm with optimized value of the normalization parameter, denoted here by A. The optimization of this parameter should be done according to the bit error rate curve. So we have to choose the normalization factor with the best correction performance. However, this optimization could be different for different codes. So here we present the results for one specific code. It is, as I remember, the code that we have taken from the WiMAX standard. But for other LDPC code, the results could be a little bit different. So the parameter should be optimized for a specific code. But the selection of the algorithm should be, as I said, the normalized mean sum algorithm is probably the best. However, as is seen in this table, it consumes a little more of the FPGA device resources, so a little bit more of ALM resources. So the normalized mean sum is probably the better, but it consumes a little bit more hardware, but it's quite insignificant, I think. On the other hand, also the selection should be based on the throughput that we, so on the speed of the decoding that we expect, because as we choose different submatrix sizes or different number of computation units in the decoder implementation, we finish the decoding in different times. So it should be also based on the expected throughput. So the communication systems are different from this point of view. So they require different throughput. So the selection of the submatrix size should be also based on the expected throughput of the decoder.
Thank you very much. It was really interesting and wide your analytics of this algorithm. So thank you again for your presentation.
Thank you very much.
And I have to now going to the end. So closing the session, I would like to thank you again, all speakers, for very interesting and stimulating contribution, and the participants for their attention. So thank you very much again, and I close the session.
Okay, thank you, Professor, for chairing this session. Thank you, all participants. Now we have a short break. We start the next session at 4 p.m. So, ladies and gentlemen, we start the next special session. It will be a work in progress session. The chairman is Professor Grażyna Suchacka from University of Opole. Dear professor, the session is yours.
Good afternoon to everyone. In this session, we are going to listen 6 presentations. Please keep to the time limits, that is 15 minutes per presentation. And our first presenter is Mrs. Agnieszka Piotrowska from Silesian University of Technology. And she will present the paper entitled Performance Evaluation of Reliable Multicast Transmission in Multi-Hop Wireless Networks.
Yes, thank you. One moment. Okay. Is everything okay? Everything is visible?
Not yet.
Unfortunately not. We cannot see your present. Oh yes, now it's
yes,
it's okay.
now we can see it.
It's okay, yes?
Yes.
Thank you very much. Okay, I will start. The title of my paper and today's presentation is the performance evaluation of multicast. Sorry, everything is okay?
No, we see a beautiful mountain, but not the presentation. Okay, now it's okay.
Okay, thank you. Sorry. The title of the papers and of today's presentation is the performance evaluation of multicast transmission in multi-hop wireless networks. I will start with the motivation for this paper and the main purpose of the paper. Then I will present the evaluated multicast transmission schemes. I will skip the details concerning enhancement and all estimation results. The multi-hop wireless networks are organized in a tree-based topology, and this is very common topology when it comes to wireless sensing networks. The main advantages of this topology is that it's easier to provide coverage, and because not all nodes have to have the direct connection with the network sync, network coordinator, here distinguished as this darkest dot. It decreases transmission power and extends battery lifetime because due to the shorter hops. Of course, and additional delay resulting from data relaying. Traditional networking mainly involves communication between 2 endpoints. In wireless sensing networks, these traffic patterns are usually much more complex. Maybe not much more, however, they are complex, and we can distinguish 3 main communication patterns: one-to-one, one-to-many, and many-to-one. All of them, or some of them, may be used in many different situations. This paper is focused on one-to-many communication, which may be used, for example, to deliver some commands from network sync network source to all other networks of the which is evaluated in this paper. Such delivery may be needed when it comes to network upgrade, and we need to deliver we need to deliver a file to all rather using one-to-one communication. What we must remember, this is wireless transmission. So even if we address only one node of a network, the transmission is received by all other nodes. Therefore, if we choose to use the multicast transmission address all nodes in a network group, using multicast should significantly decrease the bandwidth utilization. Because, however, when we trigger the multicast transmission, it will soon look like this. The transmission will be triggered on forwarding nodes, so it may cause, if the network is dense, if nodes have high number of neighbors, and this paper approaches different the paper presents different approaches to reliable multicast transmission in large data file scenario, in large data file delivery scenario, and the main objective of the proposed algorithm is to minimize the number of errors. Paper, in addition to presented in addition to proposed multicast transmission scheme, several more traditional approaches were evaluated. I will start with those more traditional approaches. First was the baseline multicast with central recovery. In this approach, the network coordinator, the source of the network, sends data packets to the multicast group common to all devices in the network. And every receiving node not every receiving node. The forwarding nodes forward trigger their transmission, so the transmission is in order the transmission reach every node in the network. After sending all data packets, the network sync selects some devices and collects the status resent. If more nodes are missing the same packet, the multicast transmission is used. If one or up to 3, only unicast transmission is used. And the recovery phase takes as long as all nodes have all data packets. Another approach is hop by hop of central recovery, and in this and the whole transmission is coordinated by the source. The basic idea is to deliver packets to the next hop using multicast group transmission scheme, and these multicast downstream packets are not retransmitted. After finishing this multicast transmission, there's also the recovery phase coordinated by the source for this following rank. And after the recovery phase is completed, the transmission is triggered on following hops, and so on and so on. And another approach is a little bit different. Only the recovery phase is different. It is coordinated not by the sync, instead the forwarding nodes collect the statuses and resend packets. This approach uses some communication primitive, one-hop broadcast to deliver data packets to all neighboring nodes, not only to the succeeding nodes in multi-hop network. And algorithm goes as follows. First, the source sends all data packets to multicast data channel. So in the first step, all file is delivered to all nodes that stay data as in traditional multicast differ starting the retransmission. It looks a little bit like this. So this is the receiving. This is what is happening at the forwarding node. First, it receives the packets. After the reception of 10 data packets, it starts forwarding. And the forwarding, if any packet is missing, it's omitted, but the forwarder waits for a time that this sending of the packet would take. This approach allows the reception of the same packet from several different sources. Therefore, different this time and waiting allows recovering from data loss. And these thresholds were all chosen empirically. And after a few moments, the situation looks like this. So all networks, all forwarding nodes trigger their own multicast transmission. And the coordinator waits until all forwarding nodes send data packets. The coordinator sets timeout, which is estimated knowing that the start of the retransmission was deferred and started after the reception of the first 10 packets. Moreover, when a node receives the whole file, it spontaneously sends status, well, some confirmation that the whole data file was received. So after sending all the data packets, the coordinator waits and collects these statuses, and which also resets the timeout after every reception. And after collecting these statuses, we come to the third step. If any node, if there are some nodes remaining that that have not confirmed the reception of the whole file, the coordinator selects up to 20% of devices. If less, it selects all of the devices and requests the status, which data packets are missing. After collecting these statuses, it sends lacking data packets using unicast data channel, and it verifies if all data back to step 3, and this recovery process takes place as long as it's needed. And it was the efficiency of this approach was evaluated using simulations with to reflect the main assumptions that we have in multi-hop wireless networks. The details were described in the paper. The simulation details are as follows. There were 3 network sizes, so 1,000, 3,000, 6,000 nodes. I tried to send 2 different sizes of files, that is 5 megabytes and 32 megabytes. The effective channel bandwidth is 37 kilobits per second. However, there was a limit for this whole file delivery process because, well, the network with its operational issues. So therefore, these limits are 10% of the normal bandwidth. So from parent nodes to successing node, it was only 375 bits per second. So it's not much. And there was one more topology parameter, which is the number of neighbors, the average number of neighbors, which is very influential for this protocol. And I will present the results for 250 neighbors on average. However, there are more scenarios evaluated. I will, during the conclusions, I will sum up how does influence the algorithm itself. The results for, yes?
We have about 2 minutes yet, so.
Okay. The simulation results for delivery of 5 megabyte files are as follows. These 2 approach, Hope by Hope, were not evaluated in further course because they produced, well, it took the longest time for them to deliver this file, and well, they were inefficient. Only the baseline multicast and SHGB algorithm was further analyzed. These are details results. However, I will skip them. Here are only for baseline multicast and this HGB process. What is significant that recovery phase for baseline multicast takes almost the whole time. This approach would require, this approach is not efficient enough to use it in this scenario. This algorithm proved is very promising. The results are independent of the network size, and because of the redundancy that it provides, the recovery phase is really short. For 32 megabyte files, the results repeated. And I also could not analyze the results for baseline multicast because the transmission of the file in a network consisting of 3,000 nodes took over 30 days. Well, simulation was shorter, however, the results were longer than 30 days. And I had to start-stop in simulations because, well, it's too much. Okay, I will come to the conclusions. The simple usage of multicast transmission may cause network unresponsiveness due to a very high number of collisions and queue overflow of timeouts, resulting in high packet drop rate. Therefore, another approaches are required in these scenarios, and this HGB algorithm provides the best results in terms of transmission efficiency and it's resilient to the network size. Further work is planned because this algorithm is dependent on the average number of neighbors. There is a threshold below which it has rather poor results. However, there's also much redundancy that is provided. Maybe it can be improved by analyzing this and introducing some probability to this multicast transmission scheme. Thank you very much. That's all.
Thanks.
Thank you.
Thank you very much for your presentation. Unfortunately, there were some lags, but I think that the slides were quite informative and we could understand. Do you have any questions to the presenter? So I think everything is clear. Could you tell what tool did you use to develop a simulator?
Network Simulator version 3. Well, the Network Simulator 3, NS3, the latest version that is now available. I'm not sure, it's 3.40, 3.30, I think.
Okay, thank you very much.
Thank you.
And our next presenter is Mr. Hamin Akram Muhammad, who will present the joint work with Mr. Ludek Lucas. And the title of the presentation is Evaluating Government and Commercial Organizations and Their Websites in Terms of Privacy Principles. Okay,
thank you.
So please go ahead.
Do you see my screen share?
Yes.
Okay. Good afternoon, everybody. I am Hamin Akram from Thomas Bata University. For today, I will present you a paper which is a research in progress for a model that we are going to create for evaluating and for enhancing and for developing the term of protection in e-governments. So this paper is in the initial steps of protecting personal information in e-governments. And the technical issue that we are working on it, I mean, the model is related to the network issues and security of the network. But in the beginning, we have to know the government that we take as an example for our model, the current situation for the government, and what are the people's attitude about the privacy information, and what are the situation of the companies that working in such government. Since I'm living in Iraq, I'm living in north of Iraq, in Kurdistan region of Iraq. As a Kurdistan region of Iraq, KRG has a long plan for toward e-government. So this research or the coming research or our model that we are going to develop will help e-government for enhancing and for protecting personal information. Really, in the Middle East, personal information in e-governments are the main issue. It's not like the situations in the Europe, since they are not concerned about this case. So in introduction, during paper area, personal information was very or private person was very protected, because in an organization only in one office personal information was stored and only a few people can access to it. While with growing computer system or information systems, this situation is changed. So at that time, many people can access to the personal information through the network. So with growing internet, or with having internet, the threat or the risk on the personal information increased. So currently we are in a risk situation for personal information, because people can access from all the world, and the security vulnerability in the systems allow people from different area to access personal information and to hack informations. So protecting personal information is not just a technical issue. It required for other levels. For example, it need for legislation for law and for organization regulations. Then need for the technical issue or technical aspect for protecting the data. In Kurdistan regional government, there isn't any law that obligate companies that working in IT solution for protecting personal information. And most of the governments, most of the organizations within the government, they not obligate or they not force it, the IT solution, IT companies to to pay attention for this aspect as we studied. And also the websites that collecting personal information, I mean the commercial websites beside to the government websites, they also not pay attention to protecting personal information. So this research will take opportunity to evaluate people's attitude and privacy principles within the government and commercial websites. I mean, within those websites that collecting information from people. The research work as a base depending on some principles for protecting personal information, which are Organization for Economic Cooperation and Development, OECD principle, Fair Information Practice, FIP principle, International Standard for Privacy principle developed by ISO, General Accepted Privacy Gap principle by the Canadian Institute Chartered Accountants, the American Institution of Certified Public Accountants, and the European General Data Protection Regulation. As you see, these principles are distributed. Some of them are international principles, some are organizational principles, some are regional principles, and also some are industrial principles. So we focused on these principles for protecting personal information, and we focused on the most common elements in each of these principles. I mean, the most common and the most repeated element that's available in these principles. So as methodology for our research, we take two methodology. One is online survey and the second is scanning. In the online survey, our data sample is 143 participants. 127 participants are the public people, are the people, the general people, but 16 of these 143 are those experts that work in the IT companies that created websites for government and for commercials. As you see, most of the respondents, I mean from the public respondents, are graduated or educational people, and they work it in government. 40% are government employees, so they are familiar with the government websites. And the other people also, they are familiar because they are educated and they use it. They use it websites. So their ratio is 46%. And for the other 60% that participated in our survey, most of them are IT managers in the companies. So they have totally understanding regarding privacy principles. Beside of them, some of them are CEO, some are IT expert. So why we make survey on them in order to ask them some questions about the state of the privacy principle in their works, in their IT solutions. And in scanning, the second methodology, we scanned 24 government websites and 38 commercial websites. So as you see, from both type of websites, these elements, these personal information elements are collected by the websites. We can say that 100% of the websites, of the scanned websites, they asking for name, email address, and mobile numbers. And some of them asking for national ID. As you know, this information, especially name, email address, and mobile numbers, are very sensitive information. It can they are used in bank accounts, that they are used in very sensitive data. So having this information by some people can be used for attacking or for hacking or for stealing information and stealing money. So this table shows the frequency of allocated personal information that is of collected personal information that is used by both type of websites, government and commercial. So as participants' attitude regarding privacy principle, in the first figure, we see that most of the people would like to have a law for protecting personal information, as we do not have such kind of law or this or any documenting that obligate companies or the IT solutions to protect personal information. Also, most of the participants, around near to 90%, would like to penalize or penalize against disobeyed companies. I mean, the companies that not obey to protecting personal information. And in third figure, we see that people are not agree, or they are not give real information to the government and commercial websites, since they do not believe to their security and to their network relation and to their attitude in using their data. And also, even they are not satisfied. In the fourth figure, we see that they are not satisfied to give their information to give a websites that they not have any privacy disclosures. In fifth picture, we see that most of people, they are not agree with transferring data to the third party. This phenomena is really very dangerous, and there isn't anything in this government for sharing information with the third party. So the companies are free if they would like to sell or to share the information with a third party. So most of the people, they do not like, 93%, they are aware about this situation and they do not like to share their personal data to the third party. And also, even the 80% of those people do not like to transfer their data with anonymous. So they are disagree with any kind of manipulating with their data. So in figure 7, we see the elements of the privacy principles that we noticed from the websites. We take 5 elements from the principles that we mentioned in the previous slides, which are notice, access, storage, security, and accountability. Our means by notice is notify users when asking for collecting, and access users for their personal information or for users data whenever he or she would like to access or to delete. And storage is related, it means that the area or the location for storing these data in a very safeguard and a very secure control. And security, the security of total network that's used between the user and between the server, and also the security of the information. And accountability means that the company or the site that use this information take accountability or take responsibility for this information that asking. As we see that most of the company, they not provide notice or any kind of notice to the users, and they do not have required access, and they do not provide access to the users when they're asking for personal information, or they not allow even to delete or to change the information. And also most of the companies, they do not have enough or adequate storage for storing data. However, they said that they have enough security, but in reality, people do not believe to this kind of security. That's why most of the participants, they not give the real information to the websites. And since of not having any kind of punishment or any kind of penalty. So most of the companies that working on the personal information, that creating IT solutions for the government and industrial commercial industries, they are not take any accountability for protecting this information. And in the last figure, we see that the kind of privacy statement or privacy disclosure that should be available in all the websites which collecting personal information. As you see, you know, there are two types of privacy disclosure, which are privacy notice and privacy statement. Only a few of them has one of these privacy statement. In industrial websites, only 11.4% of the websites they provide privacy notice, and 8% from the government websites. For the privacy statement, only 9%, and 6.5% of the websites provide this kind of privacy disclosure, while none of the websites they are not providing any kind. They are not providing both privacy disclosure both together, and 92 of government websites they are not giving any kind of privacy notice, and 88% of the industrial websites providing privacy disclosure. So in conclusion, we can say that majority of the citizens in the Kurdistan region are not ready to give their real personal information to government and commercial websites. They are not satisfied government and commercial websites to access their personal data. They would like to have a storage law or regulation to protect their data and preventing data collectors from transferring or manipulating with their information without their consent. Most of IT companies are not following privacy principles in their workers for organizations. Most of the organizations are not carrying privacy disclosure on their websites, which lead to losing their trust. So this is an initial step toward creating or developing a model. Then in the coming research work, we are working on the computer network and the security that using in such kind of websites, and security of the servers and the kind of the network between use it for this purpose. So this is all about my paper, and thank you so much. If you have any question.
Thank you very much. Do you have any questions?
Yes. Can I?
Yes, please.
Okay. Michał Sawicki, Salesian University of Technology.
Okay.
Thank you for your lecture, for your presentation. Have you checked the results of the survey? Is statistical significant using statistical test? Do you check that your results is statistical significant?
Really, statistical test is very important for any survey, but because our sample and because of the situation of the coronavirus, we didn't take a very big sample of participants. That's why we not use it statistical test on this sample. But this is a first part. In the second part, or in the coming research, we have more study on this issue. At that time, of course, we have to use statistical result test.
Thank you. Any other questions? Could you indicate any practical implications of your study?
Really, regarding the practical indication, now we are incorporating with the government in order we'd like to study whole aspects or the whole technical issues in this government that we take as an example. Then we study the weak points from each aspect or from each side of the government. At that time, we are going to the practical section. So without studying, without analysis, without understanding the situation of the current government, we cannot go to the practical. So our practical, maybe after 1 year, we reach to this point.
Okay, thank you very much for your presentation.
Thank you also thank you for this opportunity.
Our next presenter is Mr. Adam Dustor from Silesian University of Technology in Gliwice, and he will present the paper entitled Speaker Verification in Python based on Sitekit toolkit. Please go ahead. We cannot hear you, sorry.
Okay, I hope you can hear me now.
Yes, and we can see you as well.
The paper is entitled Speaker Verification in Python based on Sitekit toolkit, and during my short presentation, I will briefly discuss general ideas and present some most commonly used speaker recognition software. Then I will discuss the application used exactly in this paper, namely Sitekit toolkit, which is based on Python language, and I will present some research and obtain results with a short summary. Okay. Generally, typical speaker verification is consists of several blocks. The most important are feature extraction, model, decision, and similarity calculation. Feature extraction block is responsible for extracting from the speech signal some parameters that are responsible for recognition of the speaker. These features should have some very important properties. They should have low intra-speaker variability. They shouldn't change in time for the given speaker, and they should have a high inter-speaker variability. They should be completely different for different speakers. The similarity block is responsible for calculation the similarity between the stream of features and the given speaker model. Usually the similarity is a distance in methods based on clustering techniques like vector quantization, like k-means procedure, or a calculation of probability, which is the case in this article. For example, for the Gaussian mixture models, we have to calculate probability that the given feature sequence from the speech signal was generated by the given model of the speaker. Then in the speaker verification, we have a decision block. This decision block is responsible for taking two actions: accept the speaker when the similarity is high enough, then we decided the given speaker is really the speaker who he claims to be, or we reject the speaker when we think that this is an impostor. For the model of the speaker, we usually apply the approaches, statistical, namely Gaussian mixture models, and the other similar, or based on clustering techniques like k-means, Lindebuzo-Gray, or neural networks. as speaker verification is biometrics, namely behavioral biometrics, its error rate is higher than error rates obtained for other physical biometrics like face recognition, like finger recognition. And that's why speaker verification hasn't found so many it's not used very often in nowadays, as its error rate is too high. For an ideal situation where the speech is long, the noise is very low, it's possible to obtain very low error rates. Unfortunately, most speaker recognition is based on signals where noise is very high, especially speech transmitted through telephone line. So there are many problems with this biometrics, and we have to remember that human voice changes over time, so it's the next difficulties that needs to be overcome. Typical features obtained from the speech signal are based on cepstral parameters, namely mel frequency cepstral coefficients. How can we obtain these features? Speech signal must be segmented into short frames. For each frame, we assume that the signal is stationary. Then we calculate a fast Fourier transform, compute absolute value of this Fourier transform. Then these values we filter by filter banks, and then we use logarithm and a discrete cosinus transform, and obtain feature vectors are statistically independent and have the best nowadays the best possible properties which are needed in this recognition. As a moment. Okay. There are many approaches to speaker recognition. One is to write everything alone, but it's very time consuming and very prone to errors. So the other approach is to use ready to use available toolkits like Kaldi, which in my opinion is the most important toolkit dedicated mainly to speech recognition, but also to speaker recognition. It's written in C++ and the result is very fast. It supports, it contains linear algebra, LAPACK routines, and it's very fast, but unfortunately it's not very easy at the beginning. It's not for beginners. Very good documentation, but only for specialists. So somebody who wanted to start research in this area will have many difficulties at the beginning. The other toolkit for speaker recognition is Microsoft Speaker Recognition Identity Toolbox. It's just a small collection of MATLAB tools and routines, and as a result that it's based on MATLAB, it's very difficult to use this toolbox in commercial applications. Another very popular toolkit is Alize, written in Avignon University. However, its drawback is that it doesn't contain feature extraction and visualization tools. So it must be supplemented by other toolkit, and the most often used is SPRO library, which contains only routines for feature extraction. However, if you wanted to use this SPRO, you must be aware of one fact, that 64-bit version of this library contains serious bug, and even this bug is on the original side of the SPRO. So you have to download version without bug from the Alize website. Other toolkit is SpareBob, is a mixture of C++ and Python. However, I don't know him very much. And the last discussed in this paper is a Sidekit. It's a completely 100% based Python speaker toolkit with a minimum number of classes. It was designed to be as simple as possible with a good documentation. However, as it turned out, it's not so easy and the documentation is not so good. Main classes of Sidekit are mainly features extractor. This object of this class is used to process an audio file in different commonly used formats like sphere, wave, or raw PCM format, and it's used for obtaining cepstral coefficients for voice activity detection. The next object is a feature server, which is used for management of features, for feeding lists of training segments to other modules, for feature processing, like obtaining delta features from the cepstral coefficients, for rasta filtering. The next class is a mixture. Mixture is used for training and managing Gaussian mixture models, which are classical approach to modeling of the speaker voice. Gaussian mixture models are just a linear combination of multidimensional Gaussian distributions. There are two versions of these GMMs, with diagonal covariance matrix and with a full covariance matrix. In this paper, I use diagonal version. And the last class is a stat server, which is used for maximum a posteriori adaptation of the speaker model from the universal background model. What is a UBM? UBM, Universal Background Model, is a model which represents a typical human voice. It's trained by as many speaker voices as possible, and from this typical model, each separate speaker models are derived. Additionally to these four main classes, in Sidekit we have four additional, like ID map, which is just used to store a map between segments to speakers in the enrollment phase. Key, which is used to store information, which trial, which attempt is a target trial, and which one is a non-target. Target trial is a situation where my voice is compared with my model. Non-target, where my voice is compared with other model. Then I'm treated as an imposter. NDX is the object which covers information which segments with which models are compared, and scores contains information about calculation of the similarity between speaker segments and the models of the speakers. During research, we have to have some speech corpus on which we test our algorithms. Unfortunately, almost all speaker recognition toolkits are free. That's why we can easily test our approaches. However, data for these speaker toolkits are not for free. Most of them are provided by National Institutes of Standard and Technology, NIST, from the USA, and they are expensive or very expensive. However, one of these data, namely TIMID corpus, was from some time available from the Kaggle site. So I decided to use this corpus. And this corpus covers 630 speakers, and there are 10 sentences per speaker. This is the speech of a rather good quality with low noise level, so expected errors should be low. During my research, I implemented mel frequency cepstral coefficients as a features. 130 speakers were used for constructing a universal background model, a typical voice for these 130 speakers. And from this UBM model, 500 models were constructed. Six sentences per speaker were used for training and 4 sentences per speaker for test. As a result, I had 2,000 target trails and almost 1 million non-target trails per given order of the model. I tested the performance for the speaker model with the order of 4 to 512. 512 means that we have 512 Gaussian mixtures of the dimensionality of 512. As a result, I obtained several results. The best result was 2.29%. The results are presented for the equal error rate. This is the most commonly used benchmark performance measure in speaker recognition. And what we can see that there is small difference between scenario 1, where we had 60 features extracted from one segment of speech, and scenario 2, where we had only 19 features. Usually, people assume that the more features, the better. However, it's not the case in this example. Sometimes for good quality of speech, it's better to use shorter feature vectors than longer. And usually, results for the speaker recognition is presented on DET figures. And what is it? Usually, in speaker recognition, detection error trade-off is presented as a function of false rejection ratio and false acceptance rate. And equal error rate is an intersection point between main and diagonal of this figure with these figures. So the best equal error rate is around here. It's approximately 2%. And we can observe here two situations. When we want a very safe, very secure system, then we must accept very high false rejection rate. For example, 20%, which means that 1 out of 5 attempts are rejected as an impostor. So I would be very nervous when I would be rejected by the bankomat, by the cash. And when we want to accept almost everybody, then we had to have very low false rejection, but the false acceptance rate will be very high. So an imposter could easily get to the system. We can observe here that that there is small difference between these two figures for the 60 features and for the 90 features. Of course, the best system would be here around the low in the left down corner. As a conclusion, I would say that during this research, which is just an the beginning research in this toolkit, complexity of the speaker model has bigger impact on errors than dimensionality of feature vectors. Next, I would say that results obtained for both scenarios are comparable. Slightly better are results for shorter feature vectors. The lowest here is comparable to results obtained by other toolkits. For example, a few years ago, I presented results for Alize and SpareBob, which means that the speaker verification procedure is correctly implemented. However, there are very serious problems with parallel calculation in Python based on multiprocessing module in Windows. So I would say that if you want to use this toolkit in Python, you should do everything in Linux environment. In Windows, only one thread was possible, so the calculation was quite long. And the documentation for Scikit has many typos and bugs and needs serious update to describe the current state of Scikit development. And of course, lack of examples of how to use this toolkit with readily available speech corpus is responsible that this toolkit is not as easy as it's supposed to be. So it's more difficult than the author of this toolkit wrote. After some tweaks in recognition procedure, I obtained significantly better results. It was possible to obtain almost 3 times better results, which I think that it's state of the art for the GMMs in this for this speech corpus. And thank you very much. If you have any question, please don't hesitate to ask.
Okay.
May I ask a question?
Yes,
to the Professor Duster. Has this study tried to combine principal component analysis to identify the minimum set of features that give the best results? Because in other areas, PCA really can reveal what are the orthogonal dimensions in our multidimensional spice of the identification problem.
I'm not sure if I understood correctly.
The feature set is a multidimensional space where you try to match with the samples that you get, and with PCA and the corresponding numerical linear algebra that reduces the dimensionality, you can try to reveal the best features, because you showed from the 60 to the 90 is not very big difference. And I suppose even inside the 19, you can reduce even more.
Yes, I agree. I would say that this article was just the start for the research, because my purpose was to show something students in this area, and CALDI or other speaker toolkits are usually very difficult for students, and most of them use like Python. So I try to find if there is something in Python written for speaker recognition. So this is the first attempt. It was, as a result, more difficult than it should be. And after this article, I prepared another one where I tested many examples. And I must agree with you that there are, for some kinds of speech, especially when the speech is of good quality, the number of features could be lower than 19 features. It strictly depends on the quality of the speech. For the very noisy speech transmitted through the telephone line, then we have to add to the cepstral features their derivative, like delta features. And the resulting feature vector is long, but for the good quality, the better results we obtain for shorter features.
May I add one additional question for application? Will you plan to apply it to the speeches of species of humans that are close to dementia disease, like old professors like me?
Usually, most researchers in this area test their algorithms on on available data corpus. So it's very time consuming to prepare data because we had to collect speeches from as many people as it's possible. So that's why they are very expensive. For example, NIST 2008, it covers approximately 10 DVDs and it costs about $2,000.
Oh.
So it's very expensive. I'm not sure why this data was for free on Kaggle website. Probably it's a pirated version, but it's available, so I use it.
Thank you.
Thank you. Any other questions?
If I may ask one question.
Yes, please.
My name is Marek Saberwein from University of Zielona Góra. I would like to ask about the general performance, how fast the recognition is performed. or whether it's possible to use presented method in real or near real-time application?
Well, usually this is tested for the for a huge amount of data. So I wouldn't calculate this for one utterance, but if you would like to use it in real time, it's possible. It takes a lot of time if you recognize 1 million utterances, but for one test, it could be done in real time.
Okay, thanks for answer and information.
Thank you very much. I'm afraid that we don't have enough time for more questions.
Maybe for 500 million verification test, it took me 8 days, 8 whole days in Windows on one numerical thread to do everything for 500 million. But in Linux, it would be, I suppose, 8 times faster.
Okay, thank you.
Thank you very much.
Thank you very much for very interesting presentation. And the next presentation will be given by Monika Nycz from Silesian University of Technology. And she will present the joint work with Kamil Borsuk and Tomasz Nycz, efficiency analysis for solving systems of equations with GPU.
Thank you for the introduction. Is the screen okay and my audio is okay?
Yes, it's okay.
Perfectly. Once again, first, thank you for the introduction and let's start. I will start my presentation with an introduction to the diffusion approximation model, in which we are struggling for a long time with a few problems. The attempt to solve one of these problems was an inspiration for this research. Then I will shortly present used tools and the implementation of the test program. And finally, I will show the obtained results. For numerical modeling of computer networks, we have 2 possible approximation methods. One is diffusion approximation and the second is fluid flow approximation. From the 2 approximation, the diffusion approximation is a more accurate one. However, it is also more complex in the case of the calculations. In this method, the distribution of the number of queued packets in the buffer is represented by a density function of a properly selected diffusion process. And this process is described by a system of second order partially differential equations. Here we have the diffusion parameters alpha and beta, and those parameters reflect features of input stream, service time distribution, and queuing discipline. Generally speaking, diffusion approximation model uses FIFO queue type with passive queue management, where the distribution of inter-arrival times are defined as A of X and B of X, where B is the distribution of service times. And both of those distributions are described only by their first 2 moments, that are means and variances. And as the means, we have 1 over lambda and 1 over mu. And as for the variances, we have squared sigma A and sigma B squared. the application of the diffusion approximation model in computer networks requires that the previous equation that I showed, the previous equation of the density function, must be supplemented by at least two barriers at 0 and at n. And those barriers limit the diffusion process for situations where Q is empty or the Q is full. And here we have those two barriers at 0 and at n. The probability of being in one of those two barriers are defined as such. And all calculations of the equations are performed, unfortunately, in the Laplace domain. And to return to the time domain, we have to use algorithm. In our case, it is the Steckfast algorithm. And the key point here is the integer precision parameter L, as it defines the number of solutions in the Laplace domain that are required for single solution in time domain. And the function for which we search for the Laplace transform is defined as here. So this function consists of three ingredients. The first one is responsible for the influence of initial condition. The second component is responsible for the situation in which the first packet comes to an empty queue in a node. And the third one is responsible for situation in which one packet leaves the full queue after its service is being finished. And then we have additional parameters, G1 and Gn-1, which are the probability mass streams entering the barrier at 0 or at n accordingly. And those streams appears after a delay period given by the L0 or Ln. Those L0 and Ln are the distributions of the period of a stay in the 0 or n barrier. And then we have two more, the gamma 0 and gamma n, that are the probability density functions reaching of the diffusion process the barrier 0 or n at the time t. And in gamma 0 and gamma n, we have the additional parameters, those two, that are probability density functions that the process started at 0 time with the intensity phi and will end at time t, reaching the barrier at 0 or at n. And four more, there are density functions of the transmit time between responsive points. The unknown parameters are marked as red, and the other variables are known. And the colored coefficients, so red, yellow, and green, are the basic components of the matrix equations in the form AX is equal to B. And the matrix A is a square matrix of size n times n, and the B and X are vectors of size n. The computational complexity of solving such system of linear equations increases with the square of the data size n. For each single node in the network, for each single step, we have to solve multiple of such matrices. In other words, let's assume we have 10 nodes in the network, 100 steps of modeling, and the StackFast L parameters is defined as 13. As a result, we have to solve 13,000 of such matrices per modeling. So in our research, we aimed at examining the possibility of transferring the weight of solving many systems of equations by many independent threads to the level of the graphics card. And the second aim was to determine the potential increase in modeling performance. It is worth to mention here as well that GPU was selected rather than CPU because CPU do not allow a high level of parallelization of calculations and are not optimized for such applications. Although they have many possible available cores, as well as possibility of using instructions that allow parallel operation on disjoint data parts. The graphic cards, due to their architecture, are able to process much more data at the same time than CPU, while reducing energy consumption. And they are also distinguished by wider transmission buses to the card's memory and allow to achieve much higher throughput, which in turn allows faster data processing. And both of these features make GPU seem for us to be better suited to the posed problem. The modern graphic cards, despite rendering graphics, provides application programming interfaces, APIs, and those allow, and they are allowed to be used for purely computation purposes. And this is the application we focused in our research. There are three main APIs provided by graphic cards that can be used for calculations. And those are CUDA, OpenCL, and Vulkan. The CUDA was created by NVIDIA and works only with NVIDIA graphic cards. The other two APIs, so OpenCL and Vulkan, are both under the control of Khronos Consortium. OpenCL is much more generic, so it can be used on various graphic cards, main processors, FPGAs, DSP, or hybrid configurations. And the last one, the Vulkan interface, was mainly created to create 3D graphics. It also allows to perform calculations. However, this application is not fully developed. In other words, it does not provide libraries that would implement the required functionality using available interfaces. So in our research, we used three publicly available libraries that uses OpenCL or CUDA, and those were VienaCL, Magma, and CU Solver. The VienaCL, so Vienna Computing Library, is based on OpenCL interface. This is an open source scientific library written in C++ and provides computing facilities for CUDA, OpenCL, OpenMP. It is quite simple and provides high-level access to various computing resources available in parallel architecture such as GPU. And also it focuses primarily on typical rare and dense linear algebra operation. The Magma library, so the matrix algebra on GPU and multi-core architecture, is implemented based on CUDA programming interface. The library is dedicated to time-efficient calculations of linear algebra for heterogeneous and hybrid architectures. And the advantage of this library is the lack of necessity to know CUDA for the end user. And the last one, the CU solver, so CUDA sparse matrix library, is provided as part of CUDA toolkit, and this is a high-level package that is included in single GPU API and can be used independently or in conjunction with other libraries. The main goal of this library is to provide useful functions for matrix calculations and solving system of equations. So all three were assumed to be good libraries in our case. Of course, those libraries are also evaluated in the literature for many other applications. The program in our case was written in C++ in Qt Creator development environment. This tool allows to configure number of threads, number of systems of equations, number of the size of the system of equations, and the choose of the algorithm repetition to average the results. We have here provide the general idea of the program. In short, the program starts and either reads data from the input file or generate ones. Then it divides data into parts for processing threads. Then start particular algorithm from the library and collects the execution times of the algorithm for solving systems of equations.
Excuse me, please go to presenting conclusions, okay?
Okay.
Because I
So
think that
here we
the
have
time is...
test bed, but I should have probably 5 more minutes because I start later.
Yes, but there is 15 minutes for presentation and 5 for discussion.
I'm not joking, okay.
Okay, easy. Yeah. Easy.
Okay, so the numerical example, I will just show. We have two possible options, the sync and async functions in the Vienna library. Mainly there was no difference. The same was when we increase the number of threads. In case of CU solver, once again, we have two possible functions, synchronous and asynchronous data transfer. Once again, there was mainly no difference between those two. And in the case of Magma, we have two implementation, LU versus 1 and versus 2. And it turns out that one of the functions uses the functions from the other. So mainly there was also no difference. So in the case of different functions in one library, we did not obtain any differences. So we just select one, the representative of the library, and compare one another. So I will skip to the conclusions, as you said.
Thank you.
So the fastest implementation for the configuration with one thread, one set of equations to solve, was based on the Vienna library. However, the other data set, it was an implementation based on Magma library. In this situation, the CU solver library turned out to be several times worse than the competition. And for single-threaded case, but with more number of system of equation or bigger sizes, the fastest was CU library, and the implementation based on Magma was not much worse. Vienna CL, however, showed several times worse results. However, increasing the number of threads to 2 or 4 definitely point to the Vienna library, Vienna CL library as the best options. This work has shown that there is no particular library that is universal and optimal for our application. However, the research assumed that the best choice for a single-threaded application would be CU solver library, and for the application with multiple threads would be Vienna CL library. So in our case, Vienna CL best meets the requirements set in our introduction. However, most likely the best solution of all would be to create a dedicated computer kernel using CUDA or OpenCL programming interface. And the future works, we will focus on testing those libraries on different GPU cards, add more algorithm, more libraries, and develop a custom CUDA or even the custom algorithm on CPU to compare with GPU. Thank you.
Thank you very much. I'm afraid that we don't have time for questions. So I hope that there will be some questions later during the break. And please let us invite the next presenter, who is Robert Chodorek from Krakow.
Yes.
And he will present the joint work with Agnieszka Chodorek about opportunities to deploy the browser extensions for selective online monitoring of WebRTC transmissions in automatic manner. We have a little delay, so please keep to time limits, okay? 15 minutes for the presentation. Thank you.
Thank you for the introduction. Our paper is about monitoring WebRTC transmission using web extension included in browser. First, a short intro. We use currently more a conferencing tool and remote working during lockdown. Therefore, required many applications to build services which are integrated with typical web services for teleworking, teleeducation. Many of these services use WebRTC technology. This technology is included in current web browser. We can start this application in this currently used web browser. Also, this technology can be used in using some libraries. These libraries can be included in some program, standalone program. This WebRTC technology can also be used in this manner. Typically using only web browser interface, web browser as a basic technology. Implementation of WebRTC, sometimes it's different between main engine of web browser in some details, but using typical JavaScript adapter, we can run any program in different environment. It's different, some details, implementation details, but application can run on typical web browser. Motivation of for this work, it's need to deliver multimedia content to multiple participants located at different places with different, sometimes very poor network. Also, when we starting our meeting, it's required to start in pre-scheduled time with satisfactory quality and using a different conferencing tool, because it's not one commonly used tool. We can use several tools. Its problem also involves when lockdown will be full, when we cannot arrive in university, for example. For source of our presentation, it's also in sometimes not good high quality network. It's a problem with this sending, uploading and content to the multiple recipient. It's sometimes it's a serious problem. Therefore, it's necessary to monitoring this large session. Network level monitoring, which is very often used, for example, using an techniques which capture traffic from interfaces, also in end system, but typically in routers, for example, switches. It's not useful for WebRTC traffic because it's we're using in WebRTC and many protection technique. It's encrypted RTP transmission, real-time transmission, also encrypted some sources that for full analysis of characteristic of transmitted stream, it's not available at the network level. Therefore, it's better when we use end system level monitoring, because in end system we have many variables which are collected in WebRTC technology. It's many internal statistics about current transmitting stream, for example, current frame rate used in WebRTC. WebRTC have several internal mechanisms which allows to adapt to network condition, but to improve transmission required to analyze real problems in this transmission. Using analysis in end system, it's a problem because it must be integrated with a typical user application. Few words about WebRTC. It's used to build a multimedia real-time communication integrated in web browser. Typically, it's a special application program interface to starting this technology. This interface is written in JavaScript. And internally, we have several components which belongs to the audio, video transmission with a special method to improving quality. For example, echo cancellation, noise reduction in audio. In context in video, it's a basic transmission codec shown on the slide. Currently, we can also use improved codec also, but this is a mandatory codec for all web browser. And transport using secure RTP protocol also required some additional mechanism to transmit across network address translator firewalls that for required Stone ICE solution. WebRTC in web browser, it's strictly integrated. It's integrated when HTML5 was introduced in web browser. It's the next introduction. It's implementation WebRTC inside browser environment, and we can access to this implementation using WebRTC special application program interface. Also, we can access all functionality of web browser. To access to user application, it's one method is possible. It's using browser extension. Browser extension is a special program. Currently, it's one method of access to the browser using browser extension. Plugins are currently, due to security problem, it's not allowed in browser. In browser extension, we use our program is written in JavaScript, HTML, and also with typical formatting, and run this browser extension in browser environment and in sandbox environment. Therefore, it's safe. Then when we analyze security issue. Also, for each browser extension, we must add some permission to use additional function, for example, local storage inside web browser, and browser extensions have can read and modify content of any visited web pages. Also, user can enable or disable this Frattura of extension for given pages, but default it's enabled for all opened pages. And also, browser extension can use a special application program interface which allows to access to a special function inside browser. For example, allows to access any browser window and browser tabs. And the user can access, control access to this browser extension. Extension component is a background script. This background script working in browser extension and look at any changes in browser pages. When new browser page is opened, special script, content script is injected in this page. It's injected in new opened page and install some triggers. And after injecting, we can access to all structure. This is a structure of RTP statistic data structure. It's several statistics. It's on a few most important parameters, for example, packet loss, jitter, packet discarded, and in the level of RTC receiver RTP stream statistic. And we can access, for example, how many frames are decoded, how many came frames decoded. It's a huge statistic information inside this internal structure. Our browser extension monitor all web pages opened and detect any WebRTC activity, for example, open screen. An application starts to monitor and every changes, connection states, failures, or it's fully monitored, success or failures, it's fully monitored, and we can react to this system. Our experiments are based on two applications used in our university. One is using in my university, it's ClickMeeting. It's integrated with Moodle platform, and EduMeet, it's Jean product. It's invented in Poznań, but propagate in internal community. And this two application is a similar architecture based on WebRTC architecture. Central point of each tool, it's a special conference bridge which mix our audio signal and send information to multiple participants. That for my stream, it's only one stream. It's not depending on how many participants it's in our transmission. One most important difference in this tool, it's that ClickMeeting, it's sending our presentation directly from the server. From my side, I only send next slide only control. EduMeet transmits slides directly from presenter. Therefore, results are different. On the left, it's EduMeet. ClickMeeting, it's on the right. It's when we compare how much bitrate it's transmitted. It's only audio and small presentation, not dynamically presentation. EduMeet required sometimes higher throughput. ClickMeeting is a very smooth transmitting traffic. When we analyze in heavy traffic, it's when we analyze it's some difference working congestion control mechanism in both solution, but we can easily analyze which part of this transmission is a problem, how to tune this application. Sometimes it's possible to tune this application or suggest how to changing parameters to developer of this application. For example, changing frame rate of sending presentation or quality or some parameters which required to and go to conclusions. Internal WebRTC statistics give a good overview of our transmission, and therefore it's available only when we use peer-to-peer communication. Typical, I can write, for example, simple application and get these parameters for our application. But when we analyze typical application, required a more advanced tool, which inject code in this application. Our extension allows to store data locally or send to server which collect this data and give analysis, more complex analysis of this network. Thank you.
Thank you very much. I think that we have time maybe for one question.
Okay, I have a question. Tomasz Necz, Silesian University of Technology. You say that it was impossible to sniff the traffic because of the cryptographic, as I saw, HTTPS, that is SSL encryption. And I can't really agree with that, especially in testbed, because even if you gather full traffic, for instance, using Wireshark, all you have to do is use the function to strip SSL, and then you get unencrypted data. And if you're using in a testbed, you even have the cryptographic certificates that were used in the SSL encryption. So you know with what data you need to use to decrypt the traffic.
I would like to analyze some RTCP reports which send some details about transmission. It's also encrypted some parameters. Therefore, it's
yes, but you should be able, in testbed especially, you should be able to completely decrypt full traffic.
In testbed, but when we try analyze any traffic in a public network, it sometimes is problem.
Okay, thank you.
Thank you very much. And we have the last presentation, who will be given by Mr. Jarosław Flak from Silesian University of Technology. The paper written with Dariusz Caban. And the title is Wireless System for Dynamic Sound and Light Indicating Evacuation Routes in Mines. So I think that this is the same project as the one of presentations from the previous session, yes? Please go ahead. We cannot hear you.
Okay, now I can switch to the Zoom, but now I to share. Okay. Is this visible now? My presentation?
Yes.
Okay. So my speech is about wireless system in means of ZigBee network using for evacuation routes, especially in mines. agenda is the idea of the conception of the system. Then brief characterizing of ZigBee wireless network solution. Then presenting hardware and software components of the system, and at the end, problems and many future directions. The evacuation problems in modern times is complicated because we have large objects. In the beginning, I would emphasize that the ZigBee wireless system may be used for many objects on the Earth, as well as in mines. This is, for example, a complex building, and when an accident will be here, the people should know which is their escape routes. The evacuation systems can be divided to passive systems, like passive etiquettes or light signals, and more interested and modern active systems, which can dynamically show the evacuation routes. For example, these pictures on the right side of the slide are signs which can switch the arrow to down or to right, or to even block the evacuation routes. So this is the dynamically controlled evacuation system. The next innovation in the presentation is that the presented system signals evacuation routes using sound. This is not usual, and this is very useful because in fire we have darkness, smoke, and we cannot see any light signals. Going down to the mines, why we are starting using this system in mines? Because on the building objects there are no standards, especially fire standards for building evacuation systems. But in mines there are more freedom to build systems, because there are no boundaries in standards. The only boundary is to resistance to ATEX standard for explosion out atmosphere. But as you can see, the evacuation routes through mine tunnels would be complicated, yes. The miners should know where to escape during the accident, fire, or something else. The ZigBee network were presented 2 hours ago, so I won't repeat this. Briefly, this is based on 2.4 gigabit radio transmission. This is low throughput, and the distance is for long, several meters to even 1 kilometer. So we have low power, long life of devices, and low throughput. The standard way of working ZigBee network is this is the one coordinator in green, many routers, and many end devices. And typically a scenario of working ZigBee network are transmitting information from sensors locating in the end devices through routers to one network node called sink which is connected usually to the internet. So the routing scenario is many to one, many devices to one coordinator, one sink. But the proposed system has a reversed transmission direction, because in our system we want to send control messages to the routers or end devices. The example structure of proposed system is as you can see. This is the one coordinator. We have tunnels in mines. We have routers located and spaced, for example, for some meters, for example, by 10 or by 20 meters. To these devices are connected signaling devices, sound and light signaling devices, which indicates escape routes to miners. So as we can see, this is a logical topology as tree topology. And transmission direction is reversed to the typical ZigBee network from coordinator, which sends control messages to devices, and devices then turn on or off signaling signs. The next innovation idea is signaling by sound. And the main idea how it works is if we have tunnel with evacuation route, and the miner, for example, stands here or anywhere, the network devices should generate sound in the synchronized way. And the first one generate first short song, then maybe after seconds the second device generates sound, then third device, then fourth, and the person which stands in the tunnel has the imagination that the sound comes from one direction to other, that the sound moves. And the person naturally follows the moving sound to the escape. It requires that the ZigBee networks should work synchronized by time, which is not very easy to obtain when we have large ZigBee networks. But the generation of the sounds should be strictly sound synchronized. Okay. Something is switched on. The network has the ability to self-healing when we space network nodes closed. When the one network fails, for example, if the device B fails, then the device A could transmit the frame to the C network node, if the range is, of course, covered. In practice, the network nodes is in the distance of several meters due to the hearing of the sound from one device A and B. So the distance should be maximum 20 meters. The device networks are cheap, so the cost of the system is not as high as be seen. The hardware generally are two hardware units. The main unit network controller, which is dispatcher station, the controller station. This is the computer with a ZigBee or XBee module and the appropriate program for managing the network and visualizing network state. And the second system unit is many sensor network nodes. Network nodes are the same, are repeatedly the same units. We are built these units on Arduino Romeo microcontroller platform with Atmega microcontroller with XBee modules providing ZigBee network. The network nodes looks like at the slide. This is the main platform Romeo board. XBee radio module is put here, and then we have peripheral devices as loudspeaker, interfaces like sensors, which can be connected easily to this board. Module LED, which is light indicating and dynamically constructed arrows for one, for example, right or left direction. And we have battery also, of course. This is generally not so, this is generally cheap because the elements are not complicated. In the next XBee version, XBee 3, we can buy XBee controller with microcontroller inside it, and we even don't need an Arduino board. Software solution for network nodes is as follows. It should provide network communication, of course. There's need to develop a dedicated protocol. The software should switch the light, switch generation of sound, and reporting values from sensors. The second part of software is software for dispatcher's computer. This is central monitoring station. This is, of course, network communications, switching on and off sound and light indicators, reporting the operation of devices, for example, receiving messages or not, visualization the status of network on the site plan, for example, plan of mine corridors, tunnels, and of course, in the system, escape routers should be predefined. We have tested our system in mines. There are 3 tests. The first test should provide the answer what is the distance in mines to transfer. We have measured that to 100-150 meters is very good communication. The second test was carried out in closed devices by high voltage, and the second test with in cooperation with mining rescue team, which should with closed eyes, blocked eyes, only by listening sounds for sound indicators, go to the victim as the green arrows shows, here and here and here to the victim, and take the victim, and also with closed eyes, with blocked eyes, with masks, it goes to another tunnel. So we have dynamically changed the evacuation route to the red arrows to the other tunnel, and the test were perfectly goes without errors, without complications. So the system, we should say that that is useful. There are some problems, of course, because our system was tested at about 15 network modules. Building the system for large networks requires many other simulations and solutions. So the problems is a greater number of network nodes, network transmission methods, special configurations of network, for example, changing the sizes of ZigBee tables, address routing, binding tables for maybe multicast transmission, routing not many to one, but maybe useful as source routing. Maybe a large system should be divided to many smaller networks. So the problem is how to connect and synchronizing several networks, and some other practical problems. So innovation of the system is wireless. We don't need cables. It's easy for installation. Dynamic indicating evacuation routes and sound signaling. Thank you for your attention.
Thank you very much. Maybe one question. Do you have any questions?
Yeah, this is Udo Krieger from Bamberg University, old fire brigade man. Great talk. I have one question. The coordinator, from the logical perspective, is a single point of failure. Did you implement it in Kubernetes, including the control software on the boards? For instance, we have emulated a sensor node using the Docker framework. And this is using the redundancy of the Docker, and Kubernetes would do the same. So is this already integrated, this perspective of fog computing?
Yes, I agree. The coordinator is the single point of failure, maybe. In some conditions, it could be switched very fast. For example, it's not secured the network. But I don't quite understood if you mean Kubernetes like microservices solution?
Yes, exactly. We have implemented sensor nodes with Docker, and we are trying to do it with Kubernetes for temperature and humidity monitoring, such that we have a scalable functionality that we can deploy on variable nodes according to the loads and the needs. And such a kind of combination of microservices on the hardware, decoupling the link control and link technology is possible on Arduino and Raspberry is what we use.
Very interesting idea. Thank you for the suggestion. I didn't think about it, so
we can send you the paper, and it's free of charge and can be combined. We would be happy to support such mining evacuation system.
Thank you very much. Could you write to me on the chat now if I would know who said to me?
Of course. Thank you.
Thank you very much.
Any other questions?
Okay, so I have a simple question. Have you considered a joint work with the guys that presented ZigBee network in Mainz today earlier? Because that's you are presenting the second paper on this conference, and it actually presents ZigBee in Mainz.
Sorry, could you repeat the main idea of the question?
My question is: are you considering the joint work, future work, with the guys that presented on this conference a few hours earlier, also the ZigBee network in Mainz?
Yes, yes. The previous presentation is connected with this presentation, because the previous presentation, the goal of the previous presentation, it's our doctoral PhD candidate should present the features of ZigBee as very good to implement evacuation system in SMAN, but that his presentation was about features of ZigBee, but mine was about concrete implementation of the system.
Okay.
So thank you. Suggestion.
Yes, but the previous the co-author, Mr. Flack was a co-author of the previous presentation.
Yeah.
Okay. Thank you.
So this is the same project, I think. Any other questions? If not, I think we can end this session. Thank you all the presenters for very interesting presentations, for sharing your work, for submitting papers to this conference. And thank you very much for discussion. And that's all. Thank you very much.
Thank you.
Okay, thank you very much, Professor. Thank you for the professional guiding our session. And now we have next session without a break. This session is mine. You know, this is the specific session because usually the last session belongs to the chief of our program committee, Professor Andrzej Kwiecień. And at this moment, because because he become ill, he is impossible to deliver guiding of such a session, and I decide to make it. This session is also specific because this is the very short session. This is the shifting session from yesterday. One speech only. This speech is delivered by Rauben Kerobian, Kanik Kerobian, Karol Szubin, and Fu Nguyen from California, University of California, San Diego, and California State University, Northridge, from United States of America. And this session is shifted because of the significant time difference between our time zone and this time zone from San Diego. Unfortunately, there is another specificity of this session because we don't have a speaker at this moment. Unfortunately, Mr. Kerobian is not connected to our system. I don't know why, because we talk about the time and this shifting. So I think that we have to cancel this presentation. We don't have choice. Without the speaker, I think it is unable to deliver such a topic. So I'm sorry for that. Maybe he delivered us his presentation, his slides, and I will publish such a slides on our website, so we will be able to check it. Yeah. So now I switch to the last part of our conference. I mean the closing. I want to tell you a few words about our conference from the ending point of view. First of all, I want to say big thank you for participation, for your participation. Yeah, this year, as you know, we had a reduced number of participants due to the many reasons. The first one is coronavirus, as you know. And the second, the most important thing is changes in our national regulations. The people from Poland know this problem. The Polish Act 2.0 touched us quite badly. So we have reduced number of participants. We had 28 participations. But I hope these presentations will be were interesting for you. I hope. Generally, we had up to 54 attendees in the peak yesterday. It was yesterday, so it is quite good number, I think. Our participants came from eight countries. Yeah, it's quite good internationalization of our conference. But if we consider our guests, not only participants, not only speakers, then we have at least 10 countries which are join us. Okay, we published 2 books. The first one is Springer in series CCIS. The second, this issue is already available online. If you want to download this issue, CCIS, it is possible by our website, because if you download it outside our website, it is not possible. It is not for free, but by our website it is for free. So you can log in and download it. The second book is Studia Informatica monographic book. This book is kind of monographic, and it will be published as a post-conference book. The publisher is our internal publishing house from Silesian University of Technology. This book will be available slightly later because of the post-conference mode. Okay, a few words about next conference. We briefly decided that the beginning of the next conference, that we start this conference at the beginning of June. You can send us some suggestions if you want, but we are aware that the June is not a good moment for conference organizing because of, end of semester, some exams, some other activities, some other conferences in the same time. So I think that the beginning of June could be the good time for the next year conference, because this is much more free time for you, I suppose. I'm not sure, so I suggest to send us some comments. We plan to do this conference in real time, in real space, and as well as in cyberspace. I hope that the conditions will allow us to organize this conference in the traditional way, in contact mode. The place, the venue, the place is probably Gdańsk, but we need to discuss about it. We want to organize the next edition in Gdańsk. And the venue, of course, Gdańsk University of Technology. But as I said, we need to discuss about it with our partner. We also trying to be covered by CORE ranking. CORE is a special institution, maybe not institution, but this is the database which contains a ranking of conferences, mostly related to Australasia region, but in Poland now this ranking is quite important. So we will try to be covered. This year is the year where the new call is announced, so maybe we have a chance. I don't know. We will try. Also, we are planning to stay in contact with Springer and Sirius CCIS. It is Communication and Computer and Information Science. This is the proven partner, so I suppose that it's a good choice. If you have some other suggestions, please send us, because Springer is one book, one issue related to our proceedings, but usually we need additional books. Of course, our internal publishing house, maybe it is a good choice. I mean about Silesian University of Technology, but maybe you can suggest us additional publisher, which could be good to publish some additional books. And we are thinking about post-conference publications. It is not so easy, but maybe next year we will be able to organize such a post-conference publications in some selected journals. It depends, of course, on manufacturers. Generally, I want to request you to rate our conference. We prepared a special pool which is available on our website, so please rate the CN 2020 conference. Such a feedback is very important to us. And very valuable. So please, it is quite short pool, but very important for us. And as the last thought, I want to show you a graph. Such a chart presents the citations of our publications. I mean about all publications of Computer Networks Conference. So the conclusions is at your side, I think. So my kind request is please cite our work. Please cite papers made by our community. It is quite important for you, and it is quite important for conference, of course. So this is the last thought. And finally, I can say that the current conference, Computer Networks CN 2020, has just been closed. Thank you once again, and I hope we will see each other next year. So thank you.
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 Thank you very much.
Thank you very much.
Thank you very much.
Thank you and goodbye.
Bye.